हा सर.
येतोय ना आवाज? हॅलो, चालू कर म्हणा त्याला म्हणा ते सगळं. हॅलो, 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 हां, हॅलो, आवाज येतोय ना हर्षल? हॅलो, तुमच्या समोर ठेवा. हे बघा मी डबल डबल दिसतोय, तुम्ही यांच्या समोर राहा. आवाज येत आहे तुमच्या घाबरून होत नाही. हॅलो, बापरे, स्वाती पालक विनय हर्षलला ना. हा, येतोय का हर्षल आवाज?
हा, येतोय का हर्षल आवाज?
हॅलो,
Sir, you are audible.
हां, येस सर, येस.
हा, येस.
वाणी सर, तुमच्या नावापुढे भोजराज बराटे येत आहे.
माझा देन हो, मीटिंग होस्ट मी असं का बरं होत आहे?
आजच होत आहे रात्रीचा चांगला पाणी
हो, लिव्ह करून परत जॉईन करावं.
बऱ्याच वेळा केला.
815
हा
47.
सर,
हा, येतोय ना
माझा आवाज
आवाज?
येतोय?
हो, येतोय
हो,
येतोय येतोय.
आता
हां.
बऱ्यापैकी जॉईन होत आहे सर भरपूर.
हो हो हो, उद्या उद्या.
सुरुवात करायची का लाईव्ह स्ट्रीमिंग?
नाही, सर आल्यानंतर, मग पवार सर आल्यानंतर.
हो, चालेल.
पवार सर दिसताय का पहा, लक्ष ठेवा.
हो हो.
हे मला येतंय रे हर्षल स्क्रीन? हर्षल, हां. एकवीस आले होत नाही झालं. 21 सण आहे अजून. हॅलो. सर आले का? सर जॉईन झाले का? सर आहे जॉईन.
आहे
ठीक आहे.
ना?
रजिस्ट्रार KBC NMU
हो
आहे ना?
आहे.
हॅलो. हर्षल. हर्षल. हर्षल.
हा सर.
सर आहेत बरं बसलेले. रजिस्ट्रार KBC NMU वर सर आहे. हां आले सर आले. सर
सर
आले.
झालेत का जॉईन?
सर आले ना. हे, पवार सर आलेले आहे
एक
म्हटलं.
मिनिट मी शोधतोय त्यांना.
हे काय आहे? रजिस्ट्रार KBC NMU सर पाहत आहे.
अच्छा. एकच मिनिट सर. सरांचा
हां अजून नाही, थांब थोडं.
हो हो
लोक जॉईन होतात.
हे सगळे जॉईन होत आहे ना.
हो.
आहे सर बसले.
हो
बराडे जॉईन झालोय मी.
हो सर दिसताय तुम्ही.
हो हो.
हो हो सर वेलकम. तीस देणार. 30 सुरू करायची का काय? हां ओपनिंग सुरू करायला हरकत नाही. 80 पार्टिसिपंट्स आहेत ना. लिगाला करत ते 90 आहे ना. 30 धरायचं. 31
किती लोक जॉईन झाले?
सर 31 झाले. 31 आणि टोटल 85 90 पर्यंतचे रजिस्ट्रेशन झालेले आहेत.
बर चालेल.
आज हां 5 मिनटं सर थोडंसं.
बर.
हो हां 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 आहे सर बसले. केशव पाटील. तुमचा चालू झाला होता गजेंद्रवाणी.
हो का?
हा ना. हे बा काय हो चालू झाला नाही बा. नाव आलं तुमचं. हां डबल दिसताय तुम्ही.
हो माझं चालू होता पण
राहू द्या ना कशावर मी तुम्ही.
समोर
चालन तुमचं आला ना.
येत आहे.
यूट्यूबचं यूट्यूब.
तर
हां हां बोल.
झालेले आहेत 50-60 झालेले पार्टिसिपंट जॉईन होत आहेत.
34 झाले 34. थांब ना थोडं आले सर.
हो हो सर पण आलेले आहे.
हां सुरू करायचं का मग करायचं सुरू नवीन हां हां
जॉईन होणार.
हां जॉईन म्हणतो हां
करून
हां करून द्या जॉईन म्हणतो. हां सर्वच नाही. हां हर्षल
हा सर.
दुसरं पेज बी दाखव ना कोण कोण आहे दिसलं तर बरं होईल. सर वगैरे ते नावं वगैरे दिसते हां हां यस तिसरं बी दाखव तिसरं नावांचं
हो 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 हो.
हं. हां हां राहू दे हं, हं. आपले लोक जॉईनच नाही होतात फटाफट. हं. चालेल ना
उचलला आणि
नाही.
मेसेज पण होता.
हां हां आपले लोक जॉईन सुरू करू का हर्षल
करा सर सुरू.
सरांना हे कर फक्त ओपन
1 मिनिट थांबा.
हां सरांनाच कर ओपन बाकीच्यांना
हो हो.
नको. हं.
एकच मिनिट. हा झालेत सर.
हां सर सुरू करतोय मी सर.
हो हो करा करा.
हां सर हां सो वेलकम वन अँड ऑल. I, Dr. B.H. Barate, welcomes all the participants in this today's e-conference. On behalf of Tapti Education Societies, Bhusawal Art, Science and Pure Nahata Commerce College, I welcome to all the participants. Our management members, today's president of this conference, Mr. Mohan Bhau Palak, President of Tapti Education Society, Mahesh Bhau Palak, Chairman of Tapti Education Society, Vishnu Bhau Chaudhary, Secretary of Tapti Education Society, Sanjay Ji Nahata, Treasurer of Tapti Education Society, our today's chief guest and inaugural speaker, Professor Dr. B.V. Pawar, Registrar, Kaviyatri Bahinabai Chaudhary, North Maharashtra University, Jalgaon, our principal Dr. Meenakshi Vaikode, vice principals Dr. S.V. Patil, Dr. A.D. Goswami, Dr. Yenni Bhangale, and all the participants. Today our college is going to organize online national conference on research trends in computer sciences. So this is the very critical period for all in COVID-19 coronavirus, and that's why we must continue our academic activities, research activities. We plan to organize today's e-conference. A lot of papers we received, near about 50 papers we received from various states also, and 90 participants get registered for this conference. So our college, background history of our college is located in the Jalgaon district at Bhusawal, and we are organizing sixth consecutive national conference on computer sciences. I am very proud to say that for every conference and for each conference, Dr. B.V. Pawar is the chief guest of our all conferences. Our college is A grade accredited 3rd times and face to NAC, and we are organizing different types of activities, online activities in our college during this critical period. So I welcome one and all again, and for the introduction of our today's chief guest and inaugural speaker, Dr. B.V. Pawar, I invite Dr. G.R. Wani to introduce them.
Good morning, all of you. Respected dignitaries, I am here to introduce chief guest of this conference. Today's chief guest, Dr. B.V. Pawar, is our inspiration. He is well-known personality, but formally I have to introduce him. Dr. B.V. Pawar is a professor and officiating registrar of Kaviyatri Bainabai Chaudhary, North Maharashtra University, Jalgaon. His qualification is BE Production, MSc Computer Science and PhD in Computer Science. His field of specialization is NLP, image processing, DBMS, machine translation, web technology, etc. He has 30-year experience in teaching and research and 27-year experience in administration. He published 1 book, 4 articles in book, 79 journal papers, 29 national and 50 international papers. He presented 113 papers in conference, national and internationals. 13 students awarded PhD under his guidance, and 9 students are presently registered, and 1 MPhil student is awarded. He has worked as a ex-dean of Faculty of Science and ex-member of Management of Council, chairman and member of BOS at various university, KBC, NMU, Jalgaon, BAMU, Aurangabad, Pune, Mumbai, Gulbarga, etc. He is also RRC members, ex-director, School of Computer Science, UGC nominated as SAP Advisory Committee member of Tamil Nadu University. Okay, thank you.
I invite Dr. B.V. Pawar for inaugural speech.
Good morning, everybody. Friends, I am delighted to be here at the inaugural function of online National E-Conference on ongoing research in computer science at BO Nahata College, Bhusawal this morning. Friends, at the outset, I must compliment the patrons of this conference, Dr. Mohan Phalak, Mr. Mahesh Phalak, the principal of the college, Professor Dr. M.V. Vaikode, the convener, Dr. B.H. Bharate, organizing secretary, Dr. G.R. Wani, Dr. Gauri Patil, and entire organizing team at Nahata College, Bhusawal for envisioning a very relevant theme for this particular e-conference. I must also express my deepest appreciation to the research fraternity present here. The e-conferences such as this bring all of us together, giving an opportunity, online opportunity, by providing a platform to share and express the research among ourselves. Friends, before I talk my inaugural speech on ongoing research in computer science, Initially, what I would like to say, since many of the participants are either faculty members or students who are willing to go for research in computer science. So initially, I'll be telling you about what is basically a research, and then we'll go for different types of research, and specifically research in computer science, and what research in computer science is done at the School of Computer Sciences, KBC, North Maharashtra University, Jalgaon. As you already know, in nearly almost all the subjects, human knowledge is incomplete and the problems are waiting to be solved. We address these voids in our knowledge and these unresolved problems by asking relevant questions and seeking answers to them. Friends, as you all know, the role of research is to provide a method for obtaining those answers by inquiringly studying the evidences within the parameters of the scientific method. One can define research as a systematic process of collecting, analyzing, and interpreting the information or data in order to increase our understanding of the phenomena about which we are interested or we are concerned. Alternatively, we may define it as a careful systematic study and investigation in some field of knowledge undertaken for the purpose of discovering or establishing the facts and principles. Normally, you might be knowing that there are two major categories of the research. First one is basic research and applied research. The basic research, or you can say fundamental research or pure research, is curiosity or interest in the scientific questions. The main motivation is to expand man's knowledge, not to create or invest something. There is no obvious commercial value to the discoveries that result from this basic research. And another method is applied research. Applied research is designed to solve the practical problems of the modern world rather than to acquire the knowledge for knowledge's sake. We can say that the goal of the applied scientist is to improve the human condition or to aid the conditions for the human. And as you all know, it is obvious that the research in computer science belongs to the applied research category. And research in computer science mostly deals with designing the new framework or algorithm, improving the existing algorithm so that it will be faster, better, and giving more accurate results. Another one can be development of new tools or resolving the long-standing questions. As said earlier, I will be talking on the ongoing research or the research which is completed and ongoing at the School of Computer Science, KBC North Maharashtra University. The activities of research in School of Computer Sciences, KBC North Maharashtra University are computational linguistics and natural language processing, artificial intelligence, web technologies, information retrieval, data and web mining, image processing, intelligent systems, and so on. Basically, as mentioned in my introduction, my major area of research is computational linguistics, which comes under natural language processing. Under this particular topic, the students who have been awarded PhD under my guidance, and the topics were context-free grammar formalism and LA grammar formalism for Marathi language and its parsing using traditional parsing algorithm and LA algorithm. This was my PhD topic, and under this, I have formulated a context-free grammar and LA grammar formalism for Marathi language, and the Marathi sentences have been parsed using Early's parsing algorithm, using CYK's parsing algorithm, and Tomita's parsing algorithm. So all these are standard parsing algorithms for the natural language processing. We have modified these algorithms to make them suitable for the context-free grammar of Marathi language, and the parsing was successful. And then once I became a guide, a research guide for the computer science, the following students, they have completed the PhD on the topic of natural language grammatical inference using recurrent neural networks, automated part of speech tagger for Marathi language using limited training corpora, link grammar formalism for Marathi language parsing using link grammar parser. Another one is that particular student has developed a system called Himmat, which is Hindi Marathi machine translation framework. Then another student, he has completed name entity recognition for Marathi language. Another one is design and development of Marathi language text classification system for information retrieval. And the latest one is Preksha, which is Hindi text visualizer. This Hindi text visualizer is basically a blend of natural language processing, image processing, computer graphics, and so on. Basically, this particular topic deals with suppose if a student is dumb, he is not able to hear, but he can see. For them, if some sentence is written in Hindi, it will be translated in the form of picture, and that picture will be displayed to the physically disabled students, so that this can be directly used for the society. And the ongoing research under the natural language processing are Marathi grammar checker. One of my students is developing Marathi grammar checker. Another student is designing and developing a Marathi spell checker system for Marathi language. Another one is design and development of Marathi text to Indian sign language translation system. This particular system is again used by a society where the students who is not able to hear, for them there is a specific sign language. That sign language, normally we don't know sign language, so what we'll try to do is we'll speak in Marathi, and that Marathi sentence will be converted into sign language system, so that the students will be able to understand me what I am telling, and which will be converted into sign language which is understood by them. Another one is machine translation framework for sister language pairs like Marathi and Gujarati. And the next one is this particular student is working on computational approach for word sense disambiguation of Marathi nouns. Now, these were the topics, ongoing research topics in natural language processing. There are some other students who are working on web technologies and information retrieval. The research which is completed, they are an intelligent integrated pre-fetching and caching approach for web browsers, web proxies using data mining techniques. The next one is design of an efficient architecture for information retrieval from dynamic, distributed, and heterogeneous hyperspace of the WWW. The next one is application of ICT to promote tourism industry in the state of Maharashtra and Goa. And another one is on the web promotion techniques in information retrieval. So these were the topics on which the research has been completed related to the web technologies. And other multidisciplinary areas, multidisciplinary in computer science itself, where my students are working. One, the most prominent one is design and development of semen analysis system using microscope image processing techniques. This particular topic deals with medical image processing. One of the student is working on crop recommender system. Another one is working on automatic identification of Hindustani classical music ragas from the songs. The next one works on human age estimation using medical imagery for forensic applications. And another one is predictive modeling of academic distraction problems of teenagers using the sets of sentiments. So these are the ongoing research in the multidisciplinary areas of computer science. Besides me, there are some other guides also available in the School of Computer Sciences, and most of them, they are working on soft computing, cloud computing, image processing, and data and web mining, and etc. There are many. Friends, on this particular in this particular inaugural speech, what I try to inform you is basically what is research, what are the areas of research, what are the basic types of research, and ongoing research in computer science, which is basically the main title of the e-conference organized by the PO Nahata College, Bhusawal. So with these words, I declare that this particular e-conference on ongoing research in computer science has been inaugurated. I must congratulate Dr. B.H. Varate and his team for organizing the national conference sixth time in succession, and this one under the coronavirus COVID-19 circumstances. Organizing the conference physically at the college was not possible, and hence we must admire the idea of Professor B.H. Varate that he went for e-conference and he has provided a good platform for all the researchers, all the students who are, who are eager to do the research in computer science. I once again congratulate the organizers for organizing this e-conference and extend my best wishes to all of the participants. And I hope that the technical sessions spread over the entire day will be helpful in your research endeavor, and as an outcome, it will contribute to the theme of the e-conference. Once again, I congratulate and I thank one and all for participating in this particular e-conference, and I must thank the principal and Professor B.H. Varate for organizing this conference and for inviting me to inaugurate this conference. Thank you very much.
Thank you, sir. About research, your note will be helpful for the younger researchers, and such a nice note on current research. All of you know that today's current researches are going on NLP and machine intelligence, and Dr. B.V. Pawar is working on such a innovative topics and guiding their students on NLP and artificial intelligences. Sir, your cooperation help us for organizing such activities, and thank you for your cooperation again. Now we are starting our technical sessions. Our first session is from Mr. Naveen Singh, working in Peninsula Via as a software architect. I invite Dr. Giarvani to introduce Mr. Naveen Singh.
Now I would like to introduce our resource person and feel proud to say that he is our alumni of the college. Naveen Singh, he is presently working as middleware architect at Versum Material US, holds master degree in computer science from Wadia College Pune and bachelor degree from our college, brings overall 28 years of technology and delivery management experience in global IT with key focus in integration platform as a service, iPaaS, enterprise application integration and middleware technology. About 10 years ago, he has defined and implemented his first middleware strategy for FLS Meet Incorporation. Since then, he has been engaged in a variety of middleware projects involving iPaaS, A2A, B2B and ETL requirements. Recently, he has been doing much work with cloud and hybrid integration. I welcome Naveen Singh to deliver a lecture. Welcome, Naveen Singh.
Thank you. Thank you for that introduction. And, I hope you can hear me well. Thank you. Like Professor Vani said, I studied my bachelor's degree from the PO Nahata College. That was many years ago. I was thinking about it. I'll give a quick introduction about myself. 89, 90, 91, 3 years. That ours was the second batch from PO Nahata College. And it was quite infancy, that's when this whole journey started of computer science. The computer department was pretty new there. And it was good to hear the talk earlier and see the kind of research that is going on. So, from 30 years ago when the journey started till now, the kind of work that is going on and how the department has matured, I really feel proud to hear all of that. So after 91, I went over to, because we didn't have the master's degree in the college. So Pune Warrior College was the next option, and they had the master's degree over there. So I did my master's, and then from there moved to Mumbai. That's where I worked for this consulting firm, Pricewaterhouse. So did about 4 years of consulting, and then moved over to US. Did a lot of work in different kind of technologies. Played different roles, did project management, did line management, did a lot of application development. And then for the last about 15 years or so, I sort of chose to be in the middleware space. And particularly, you can see in the last decade, a lot of cloud technologies have evolved. And so on the middleware space also, the platform is called as integration platform as a service. So it's a service delivered off the cloud, and it's basically any other platform as a service, but you just put the I in front of it. So the last 10, 15 years, I have been very focused in this space. So I would like to share my experience, let me share my screen, then I have a slide deck here in front of me. So I'll run you with all the contents. Okay, I hope you can see my screen. So in the contents, I had a lot of slides, and then I thought that, okay, we have about an hour, and I don't want to confuse the audience and confuse you all with flood you with a lot of information, and you come out of this hour and then find yourselves confused. So what I did was I trimmed, and I basically kept it very focused in the IPaaS area, and so I've cut down a lot of other slides that were there originally. So I've kind of made it quite brief. So my intention is that, maybe the next 30 minutes or so, I will run through the presentation, and I will go through these various subtopics within the IPaaS area. And maybe at the tail end of the hour, we can leave a little bit of time for question and answers. If you just have some curious questions, feel free to ask, and then we can address that. So the agenda is basically, I'd like to give you an overview of how data integration and the middleware space has evolved, right? So what were the past data integration trends, what people did, and what technologies existed, and how it has evolved so far. And then, we'll go into what are the emerging trends for the future, where are we heading, and what are people and what are specifically, what are vendors offering, right? So there are a lot of good vendors, big vendors, and they're offering a lot of solutions. So, what is the trend over there? What does Gartner say about what's the future? And in between that, between the past trends and the future emerging trends, I have embedded this second bullet points, which is the integration patterns for scalability. This is nothing but concepts, so I will talk a little bit about the principles of integration, so what principles you should follow, what concepts you should apply. So this is more theoretical, but this is just about the mindset about, when you are designing or when you're architecting an integration or a middleware architecture, what are the priorities and what are the things you should keep in mind, right? And then we'll jump into the platform itself. What is exactly an iPaaS? There are a lot of acronyms in today's world, right? There are a lot of vendors and there are a lot of cool sounding names. But what exactly is this iPaaS, And we'll try to dissect that. And I will get a little more specific about, talking about Dell Boomi, because that's one of the platform. I worked with a number of platforms, but Dell Boomi is my most recent undertaking. And it's also a platform that is on the cloud. So, it's a very good example to take as a use case. And then I will also show you a little bit about some technical architecture of how the various components that are within this platform, right? So what are the individual components and their interworkings and what is needed in there? So let's jump into it. Past data integration trends. I started my career, like I said, started from 93 and then, did a lot of application development. And when you do application development, there's always a need for integration. You develop an application and then, you buy something else and then, there is another application that is being developed and then you have very soon you find out that you have multiple applications and you have to, have the application talk to each other, right? And I've categorized this. These are more kind of standardized terms now these days. A2A integration, which basically stands for application to application integration. And then there are B2B integrations, which is more a business to business integration. So, when you are a corporation and when you're dealing with partners, right? You have vendors that you deal with, you have customers that you deal with, you have banks, there may be supply chain partners. And so a lot of these partnership has some sort of data exchange, so those are all under the category of B2B integrations. And then there is a very large area of reporting and analytics where, reporting used to be kind of an extension of an application, right? So you have a bunch of screens and then, you have a bunch of reports. But in today's world where we have tools like Tableau, we have QuickBase and Power BI and so on and so forth, right? There are a lot of good, cool reporting tools. Tableau is one of the famous ones or I should say a popular one. In a world like that, there is a lot of analytics happening. People have a lot of data, organizations have a lot of data, and we want to find meaning out of them, right? So we want to be able to derive, decision-making processes have to be informed by the volume of data, right? And the kind of data that we generate in today's time, it's enormous, right? And you need some sort of a tool to be able to dashboard them and be able to show some meaning out of them, right? So Tableau kind of reporting has really taken it to the next level, and data warehousing and data mining and all those things. I just bundle it under the ETL category because ultimately that's what happens, right? For you will have some sort of a data lake or a data warehouse, and you will extract and ingest data from all these various sources, bring it to one area, and then do kind of cool dashboarding on top of them. So talking about the past trends, not all of these topics are sort of obsolete, right? I mean, a lot of them are very relevant. But then let me start with A2A. In the past, we used to do a lot of point-to-point integrations, right? So you have application A and you have application B, and at the most you will agree upon some kind of a staging table arrangement, and then you do point-to-point integration. So A, if it needs data from B, it basically goes and interfaces with B, and then if B needs data from A, it will have some sort of a direct interface, where it will talk to A. And that was the trend. And in some senses, people still do that, but it is sort of becoming obsolete now. People are using a bit more they're putting layers in between. And so, the point-to-point sort of evolved into using some kind of a queuing mechanism, right? So there will be a queue in the middle, and then use the queue, right? So if A and B have to talk, A will post a message on the queue, and then B will read the message from the queue, right? So that was sort of how integrations started evolving into. And that queuing was again evolved, and then it matured into enterprise service bus kind of integration, right? So enterprise service bus was nothing but and people still use it. It's not completely obsolete, but people are going beyond ESB now. ESB for, I would say, the last 2 decades was pretty solid. Everybody wanted to do integration through enterprise service buses. Now, enterprise service buses were nothing but they were glorified messaging queues. So it was sort of an evolution of the messaging queue, where you can post messages on the bus. Bus was nothing but a queue. So you post messages on the bus, and then there will be subscribing applications would read messages from the bus. But then the bus was more than a queue, right? So you would have connectors, right? So depending upon the different technologies. So if you are doing a web service kind of an interface, there would be a web service SOAP connector or a REST connector. Or if you're doing an FTP, there will be a FTP connector. Or if you're connecting to a database, there will be a JDBC connector. All sorts of, no matter what kind of, if you're connecting to a mainframe system, let's say you're connecting to a COBOL-based database, there will be a connector for that, right? If you're connecting, your data source is a CSV, comma separated file, there will be a connector that could read the CSV file from there, right? So ESB was the next level of evolution from the queue-based integration. And ESB is still very, and I'm one of the, there are use cases. There is no single solution that kind of is a silver bullet for solving everything, right? So there is always, you can pick any solution, and then it fits well for a particular use case. But then, if you kind of change your use case, it may not be a good fit, right? There may be another solution that fits better over there. So ESB still heavily gets used in the industry, but people are getting more into a bit more sophisticated integration platforms. Service-oriented architecture, again, was, I don't want to make it sound as if it has gotten obsolete, but then SOA was a big thing. Everybody wanted to go into SOA. They all wanted to virtualize their services. They all wanted to make, expose their services as web services, so that consumers, external and internal consumers, can just consume those web services and then consume data, interact with your application and things like that, right? But service-oriented architecture is kind of changing its shape, I would say. These days, if you look at the modern application architectures, people are moving towards microservices kind of architecture. You would have heard about a lot of companies are designing microservices architectures. I think it's sort of a evolution of next step of evolution of the service-oriented architecture. So a lot of, I mean, if you look at the foundation of microservices architecture, a lot of the concepts are kind of SOA concepts. You know, it's just refined, and kind of some of the challenges that SOA had was addressed, and you know, they've become more um, uh, kind of microservices architecture thinking. And then B2B, pretty much, you know, you can do a lot of API based integration, or there will be, you know, a lot of people did EDI based integration. So, you know, those standard EDIs, you will have a purchase order EDI, you'll have invoicing EDI. There are all these standard documents that, you know, if you're dealing with bank and you're making a payment, right, there is a standard bank payment EDI. So a lot of the B2B were very EDI heavy. EDI is, again, you know, it works. So a lot of banking oriented, a lot of financial services oriented organizations, and a lot of supply chain organizations, they are still into EDI, and they still heavily use EDI integration. And so that still goes on. And reporting, I already mentioned. So with that, let's move on to, I'd like to talk about a little bit about the, here is a screen which I was sort of telling you about, the point-to-point integrations, right? So this is kind of a good diagram that depicts point-to-point integrations. So what happens is, you know, when you start doing point-to-point integrations, it's very efficient, right? It is very fine-tuned and fast. Performance-wise, you will have a faster response. But what happens is that, you know, you start with one, and then you make second, and you do third. And then in a couple of years, very soon, you find out that, oh, I have ERP systems, I have HR systems, I have procurement, vendor kind of systems, and then I have a CRM systems, and I have n number of systems, right? I mean, you can see here, and they all want to integrate and talk to each other. And very soon you get into this kind of a setup where it's like a web of, it's a mesh of integrations. And you can imagine, you know, when you have something like this going on, it becomes unsustainable. It becomes very hard to maintain, and your maintenance cost becomes really high, right? So this was one of the single biggest reason why people moved away from point-to-point integrations, and they wanted to find a better solution around it. So going to the next slide here, I talk a little bit about what are the right approaches, right? So point-to-point integration, like you saw in the previous slide, it creates tight dependencies, and it progressively makes it more complex. And the architecture, you know, when it becomes complex, you are dependent upon a lot of people maintaining it, right? And then your response time becomes slow. But what we need today is we have mix like this, right? We have all these components around, and we want them to talk to each other, but we want them to talk to each other in a more simple and in a way where you can manage it, right? So what are the concepts we should be using? Because we need scalability is one of the things we need, because we cannot invest into a lot of these effort of development and then, you know, figure out saying, oh, we have to lose this, right? So whatever we do, we should be able to scale it. And then, you know, tomorrow you grow, your organization grows and doubles, let's say, you know, you should be able to just scale up and scale your infrastructure to support that. So one of the key thing is that you need to be able to have, for scalability, you need to have a decoupled architecture. So you know how in the previous slide, these are very tightly coupled. You know, when you talk about having all these lines going from one place to another place, what happens is that, think about it, my SAP system, let's say, right? This example, if you take SAP R3, now this is a really, really old version, but my SAP system, SAP comes and says that we have a new version and you have to upgrade it because we will stop your support in whatever number of, like maybe another year or so. You have 1 year, you have to upgrade it. If you don't upgrade it, you lose the support, right? So now you're forced. Now, if you have to think about it, if you have to change this, think about how many integrations are coming in and out of this one component. You literally have to shake up the whole organization, and you have to talk to these people and then test your integrations. You have to test integrations with literally everybody. And that is unsustainable, right? What happens is that your upgrade becomes a bigger project than the upgrade, right? So the key is to be able to design an architecture where you should be able to upgrade your applications with minimum effort, and not only from a time perspective, but also from resourcing perspective. So a lot of organizations, so that's one of the concepts that you have to remember. Like I said, data consumption has become one of the key elements in today's organizations. And I'm talking from my own organization. I've worked for multiple organizations, and provisioning for data consumption by the end user is one of the biggest demands in my organization today. Because what happens is there are a lot of data everywhere, right? ERP has its data. We have all these cloud applications, CRM, Workday, ServiceNow, and all these cloud applications, and there is a lot of data being produced. And on the other hand, what is happening is that business is no more dependent upon IT to develop reports, right? Business has what we call as citizen developers, right? So business themselves are pretty involved in developing their own reporting, right? So Tableau, kind of a breed of reporting tool that is available today, has so much of capability that you don't need to be IT. A business user can pick up Tableau, learn, and basically can connect to your data source and develop their own reporting. And that's what is happening in my organization. We have a bunch of Tableau users, and all they want is data. Can you just provide us this data? We need sales data. We need procurement data. We need supply chain data. We need financial data, right? Just provide us. We will build our own reports. So what has happened is provisioning of data for their consumption has become really, really critical today. And as a result, integration platform has become very critical, because how do you provision, right? Because think about financial data. There is a lot of data that has regulations. In my organization, we have a lot of export controlled data. Now, we cannot just provision that because you don't know who is using that, how they're using that. So when you provision it, it has to be in a secured way, has to have proper governance around it. So think about all these things. They kind of demand integration to be more than just data flowing from point A to point B, right? Also, today, the business functions, because of the presence of cloud solutions, businesses are not always coming to IT. They are going to the market directly. I know in my organization, a lot of people, they buy their own Tableau licenses. They buy their own applications that are cloud enabled, and the vendor supports them, and business departments, they will pay for the licensing, right? So IT is essentially involved in, not in a very kind of a direct way, right? So in those kind of situations where business is picking their own solutions, and we want to enable that, because if you stop them, it is not good for business, right? I mean, you want to be able to, either as IT you enable them, or you support them when they are finding a solution out in the market, right? And I already talked about these decoupled integrations. So when you have that kind of a mix, right, there are so many on-premise, what we call as, any application today that is on your own server that you own inside your building, they're all on-premise servers. So you may have applications that are running on your premise, but more and more organizations have a hybrid kind of a situation where they have a number of applications running on their premise, and they have solutions like Salesforce, they have solutions like Workday, they have solutions like ServiceNow, and there are a lot of supply chain kind of Ariba kind of solutions that are available. And so you, in your organization, you have a bunch of cloud applications and a bunch of on-premise applications. So again, integration becomes really crucial and essential, because these resources are not even in one place geographically, right? And add to it, when you are a global organization with operations all over the world, right? Australia, Asia, Europe, Americas, and how you are connecting these applications around the world, it becomes, it just adds another dimension to how you think and how you design your architecture for integrating all these applications. And one last thing I would say, I talked a little bit about decoupled, but I have another slide to explain what I mean by decoupled integration. So I'll wait for that slide. And a use of canonical data models, and the use of publish and subscribe integration patterns. So I have another slide. I think that would be better. We talk about both these topics in that slide. Yeah, very quickly, I picked up the slide where it shows integration kind of from bottom up, start from bottom up, right? So if you look at the very bottom, application B, you have direct lines going across, right? And this is what I call as point-to-point integration. But then you also have request and reply, right? So you make a call to another application, and that application responds back with some sort of a data, some sort of a response, right? So again, that's a request and reply, but still very tightly coupled. So if you go as progressively as you go from bottom to up, they are at the bottom, it is extremely tightly coupled. And as you go progressively, they become more and more decoupled. And the idea is that you need to design your integrations more that are kind of decoupled, right? Because the more tightly coupled, the heavy price you pay for maintenance, and it becomes more fragile. So you change one small thing, everything falls apart, right? I mean, you get into those kind of situations, and you get a lot of errors and things like that, right? Somebody made a small change, and then all of a sudden, completely unrelated part of your organization is complaining because something is failing over there, and we didn't think about the consequences, because the dependency is so much that it's just fragile. So, and very quickly, message parsing, this is what I mentioned about the queuing concept. You put a message in the queue, and then you dequeue it, whoever is the consuming application or whoever is the receiving application, they will dequeue and read from it. Publish, subscribe kind of is the service bus concept, where you publish a message. And these are examples of, I'll give you a good example of master data, customer, let's say, or a worker, right? An employee database. Employee is used literally by every single application, right? No matter where you go, whether it is an ERP application, whether it is a supply chain management application, whether it is some kind of a reporting application, no matter what, worker information, employee information is always needed. So worker, let's say, is a really good example for publish and subscribe, because, you know, in your HR system, when a new employee joins or an existing employee's data is updated, that record on that event, you know, create or update event, there will be a publish event, and there is a publish document that happens onto the middleware or onto the bus, you can say. And by bus, I mean ESB, Enterprise Service Bus, or it could be anything that is a middleware space, you know. And when you publish that on the ESB, it would know, saying that whenever employee message is published, that message has all these number of subscribers, right? So there may be 5 different applications that need employee information. They would subscribe to it. And as soon as the publish is made over here, they will all receive that message. So that's a very decoupled way of integration, because what happens, think about it, if application C was down, let's say, it would just queue up here, and, you know, there may be more and more messages coming up. It just queues up here. And afterwards, when application C comes up, all of that will flush into that application, and it receives, it doesn't miss any of the information, right? So that is the concept of publish and subscribe. This is another slide of publish and subscribe pattern. You know, application does some data mapping step, and the middle model, you know, is called as canonical, but it's just, you know, don't let the term confuse you. It's just a neutral model, which is an enterprise data model. It's called as canonical data model. So you publish that in a more neutral format, and then from there it gets subscribed, because not all application needs all attributes, right? So some needs, you know, maybe the first application needs the first 10 attributes. The second application might need the last 10 attributes, right? So depending upon what they need, that's what they get delivered. So that's a good pattern that to follow, because, you know, if you have a third application coming in that needs the same data, all you do is put a subscription, and you don't need to really bother application A. Or if you need to replace one of these applications, you could easily just work on that particular end, and you don't need to disturb any other components. Very quickly, I don't want to spend too much of time into the emerging trends, because I know we need to jump onto the iPaaS topic as well. Emerging trends, a lot of data integration topics are becoming more than data integration, right? So they're getting into more process integration. My example of worker or employee data, applications need employee data, but then now an example of process integration would be like organizations are implementing worker onboarding and offboarding processes, right? So it gives you employee data, but it is more than that, because it's the entire process, right? So when HR kind of finalizes somebody's hire, and let's say somebody's joining from coming Monday, they'll put that in the database. And coming Monday, when the employee comes in, they already have their credentials created, their email is created, and then, you know, their account information, access, their laptop, everything is ready, right? Because all of that process has been integrated, and then, data has been sent everywhere, and then we do that, so what we do is, like, if somebody is joining Monday, on Sunday evening, there will be a trigger that goes and then does all of these information. And then, there's an email that's sent to the manager, which will say, okay, here is your new employee information, here's the password. And when the employee comes in, they already have everything to start, right? So that's like sort of the process level of integration. There's a lot of IoT scenarios today. As we know, it's not only computer talking to another computer. A lot of our devices have become smart devices now. So, there is like devices, really smart devices talking to each other, and they all need integration. I already talked about hybrid integration architectures because we have all these on-premise and cloud resources. And today, actually, there are, like I also gave you example of Tableau. There is a role called, there's a very popular role in a lot of organizations of data scientists. And data scientists are pretty technical people. They're almost IT, but in a lot of organizations, they're not part of IT department. Data scientists are roles that are embedded within the business organization. And again, a lot of API-based connectivity, microservices architecture, they all need a data integration platform. So I built that large background for you to take you into this topic of iPaaS. iPaaS is sort of the next evolution of the integration platform. So in the past, there used to be a tool for ETL. There used to be a tool for application to application integration. There used to be another tool for B2B integration, right? So they were all independent tools. ETL, one of the popular one is Informatica, right? A lot of people use Informatica. And they're still there in the market. And there are a lot of new ones coming in, right? I'll give you an example of Dell Boomi, but there's MuleSoft, there's TIBCO. There are a number of applications. What has happened is that iPaaS space has captured all of those areas, right? So there used to be API management tools, right? iPaaS has API management. It has ETL capabilities. It has A2A connectivity capabilities, and it has B2B connectivity capabilities. So all of that in one platform is called as integration platform as a service. And then, think about it, you could, of course, there are platform integration platforms that can be installed on your premise, but because of the maintainability and the capability of cloud services, these iPaaS services have really taken over. I mean, it's low cost, low maintenance, so has become very popular in the industry. Here is an example of the Dell Boomi offering. This is one of the slides that I picked from Dell Boomi's presentation. And you can see that ETL, application integration, EDI, which is B2B, API management, master data management, workflow management. All of that in one platform. And if you look at the outer circle, you can connect your on-premise applications, your IoT devices, your mobile resources. You can do a lot of data analytics oriented integration, social, because a lot of organizations have, social media data, right? I mean, they're heavily mining Twitter and social media data. B2B, primarily a lot of use cases here are the EDI based integration. And then of course, cloud integration, right? Some of the key features are, it gives you off the shelf connectivity data transformation capabilities. So, you can easily connect from, let's say you're connecting your Workday to your, let's say, your ERP, right? Workday connecting to ERP. Now, Workday gives you an XML format data. ERP demands, let's say, JSON data, right? You can easily have connector transform the XML data, read it, transform that again into JSON data, and deliver it. All of those almost in a plug and play kind of fashion, you can connect, transform. And so it's not only data format connectivities, but also different transportation protocols, right? So you may be connecting over HTTP, you may be connecting over SOAP, you may be connecting over whatever, FTP, SFTP, or even some kind of messaging, FAFCA and any other kind of MQ type of connectivity. And then you have all these standard application connectors that come standard built in, so you will have SAP connector, so Workday connector. So when you want data from Workday, all you do is just connect your Workday and you can browse business objects, so say I need HR data and I need employee data. So they're all business objects that you can browse and then and pick. Right? And it gives you all those capabilities of ESB, like I told you about, publish and subscribe, request and reply, and all kind of event-driven integration. That gives you all those kind of capabilities. And also, a lot of these application ones are like you need fast and because they are transactional. Right, but then ETL falls in a different category where you have higher volume data, because what you're doing is large amount of data, sometimes gigabytes of data are being transferred and extracted and on the flight being transformed and loaded for consumption. So all of that capability. Here is a very quick technical architecture. Just to show how the cloud thing works here. Now, you might see this gray box here, but on the left-hand side, that is the development. This is where all the build happens. So this is all a cloud platform. So the Boomi platform, I take this example of iPaaS, which is a Boomi platform. Now you could take MuleSoft or you could take any other, so I'm not suggesting that this is the only platform, but any platform you can take them. This particular platform allows you to do the build and everything on the cloud. And then from there, when you have built your flows, you can deploy them onto the runtime, right? So the runtime can also be on the cloud, but in this example, just to show you, I picked this example where your runtime can be on-premise. Typically what happens is that in an architecture like this, your runtime should be close to your data resources, right? So in this example, I took SQL Azure. So this is a cloud resource, my SQL server that is sitting on the cloud. Workday is a cloud application, but my SAP is on-premise. So I have a hybrid. Now, where should this atom be? If I didn't have this on-premise thing, I might have as well put this atom on the cloud, right? So it's quite possible. So you can have multiple atoms depending upon how you want it. So this is just one technical architecture. You can have multiple configurations of this. The runtime is called as atom. So yeah, so the runtime is nothing but a JVM. So the runtime is just a Java virtual machine. They have a fancy word of calling it as an atom. Like here, same in a different view. This is one of the configuration where you do all the building over here, all the development over there, and then for runtime, you can spin your atoms wherever you want. Now, this is one example, which is sort of a real example that I did. Even though we're not using the Boomi atom on the cloud, but we're using Microsoft's Azure, where we have spun the atom. So it's on the cloud, but it's just in our cloud because most of our resources are on Azure, on Microsoft cloud. So we wanted to keep the atom close to those resources because when my integrations are running, they need to have access to the data, and it needs to be close in the close proximity. That is all I have. I have one more slide, but at this point I will pause, and I think I've spoken enough. And if you have any questions, I will leave this open for you. But if not, I can jump onto one final slide and then show you that. Any questions?
Hello.
Yes, sir.
If any questions are there, please ask some questions. So Naveen, basically all the participants are researchers, and they want to know about the iPaaS services, and where can we use the iPaaS services in our research area. Like our research area is nowadays, that is big data analytics, natural language processing, image processing, information security, data mining. These are the research areas are strongly coupled with this side, and that's why how can we use iPaaS services in such a type of research areas?
So, I mean, basically, you could, whatever, if you have data sources that are scattered, right? I mean, they are not in one place, right? If you have data sources coming from in different formats, from different applications, or it doesn't even have to be different applications, right? I mean, they may be saved in a database, or if you have situations like that, iPaaS is a good good case, because it doesn't need much investment. All you need is licensing, and depending upon which vendor you go to, like this one, it goes by the number of connections, right? So they will give you some kind of okay, the first 15 connections is so much license, right? And then the next 10 would be additional so much, right? So it goes by the number of connections. So as a research student, if you are, I mean, if you're just doing research, I'm not too sure about that, but if you're really, doing some kind of work also, right, where you are really mining data and pulling data and processing data, you can certainly use iPaaS, because that is exactly where it fits, and you can like I said, you can buy based on the number of connections, and you have to pay based on the number of connections. So you don't have to, buy an expensive platform where you are, you're not using it, but you're paying, right? So here, this is like, you're only paying for what you're using. But I would say look for different vendors, because there are there are a lot of options, for research kind of situations. Again, vendors will give you, because their pricing models are different, right? When you go to a corporation, their licensing is more expensive. But if you go to an educational institute, vendors will have much more different structuring for pricing. But yes, I mean, if you're involved in pulling data from a web resource, because a lot of data is available on cloud resources today. A lot of research data is available. I quite often go to some cloud resources, and then there is a lot of public data available. All you have to do is go create an account and subscribe to that data, and you will be able to pull it. So if you have situations like that where you're pulling data from different sources, iPaaS is a really good case. But also, I would say one more, Professor, is that iPaaS is more kind of a suite of platform, a suite of products. So it's huge, so it might, I'm also afraid that, it might become an overkill, because if your cases are very limited, bigger organizations, what happens is that they have, like in our case, there's like 75 Tableau installations. We want to, because really there's no need for 75 installations, we want to consolidate them. There is so many databases, and so we need platforms like that. But in research kind of situations, it may become more, there may be a better option either for research rather than investing into something that is too big.
Can we use any open sources for working on iPaaS?
That is exactly what I was thinking. I am not, I don't have anything off of the top of my head, but I am pretty certain that there are open resource options available where, it might be limited to sort of the volume and, so there may be some kind of constraint and limitations to how you use that, but I'm pretty sure that you should have open source availability.
If anybody has any questions, please ask. Otherwise, Naveen will continue his lecture.
So I have, I'll continue with one last slide. I just have one more slide.
Yes,
And
yes.
then if you have any question by then, if you think of something, feel free to ask me. Here is a sample use case. Now this is it's actually a real case, but I've kind of removed some of the specific names because, as it says here, pursue materials confidential. This is from my work. So this is one of the projects I recently worked on. But it gives you a really good example of all the cloud resources and on-premise resources involved. I'll give you a little explanation of what's going on here. Look at the firewall here. Everything in here, inside the firewall, is.
Are you sharing anything?
Oh, hold on. Did I lose my sharing?
No, continue.
Yeah.
Okay. You
I
see my
think you need
screen,
to
right?
share the slides, Naveen. We don't.
Okay.
ओपन झाला होता.
Okay, you see my screen now?
Yes, yes, yes.
Okay, okay. Sorry, my apologies for that. I
किरण
guess
नाम
it just dropped at some point, and I did. Okay, so here is a slide that is from one of my recent work. I kind of masked some of the specific information, but like it says here, Versu materials confidential. This is like one of the recent project that I worked on. And but this was a good example that I wanted to share with you because it gives you a good overview of what is going on here. And there's too many components here actually, and there are a lot of cloud components, and there is a lot of on-premise component. So let me run you through step by step. If you look at this line here, dotted line here, that's the firewall, and everything on the left is inside the company network, right? So that is inside the firewall. And anything all outside this, which are these two components basically, they're outside the firewall. Here is the Atom, iPaaS Atom. So this is the green box is essentially the iPaaS platform. And so all the flows, these small boxes that you see in here, they are individual packages of flows that have been built. And they're pretty complex packages, So the first one, if you see, it refreshes the SAP data. So there's a bunch of OData services through which, through the NetWeaver gateway, data is pulled from our SAP system, and then it is brought into the SQL database, right? So there is a SQL server on the cloud. There is also on the cloud SQL Azure SQL server. So data comes from here. This process essentially pulls data and then puts data over here. So you can see what is involved. There's OData service, which is basically a protocol, a type of a standard protocol. So that protocol is used over here, consumed, and there is a OData service connector that is used by the iPaaS platform to consume this data. And once it gets the data, it goes and connects to the SQL server, which is on the cloud. It connects over there and then pushes all of that data over there. And when you pull data, there is a lot of pagination and things like that, right? Because this is really streaming data from here. So it pulls data kind of depending upon 20,000 rows and then 20,000 rows and 20,000 rows in chunks of pages, and then populates that. The second one is configure one, which is a forecast data. Now this is a SQL server here. So this is an example where it pulls SQL server data and then it puts that data into another database. It's an analytical modeling database, and it does more than that actually. So it pulls this data, it pulls, so on the input side, if you see, there is SQL server data, there is some Excel files, because business will run some reports, generate some things, and then they will have this monthly inventory data prepared, and which goes onto a file share. And then so that Excel data gets merged and then read from there. And then there is a lot of compilation that happens, because so there's a third one that comes from here. So 1, 2, and 3. So 2 SQL server data and then Excel file, all of that gets merged and summarized. And then that output goes into this analytical modeling database. And then there is this process that essentially exports. This is just read and export. It reads all this data from the analytical modeling database, and it sends it out onto Microsoft Azure Blob Storage. So this is also another cloud storage. Microsoft Azure has this concept of blob storage. So you can have a blob account, and then you can create tables there. You can just copy files. You can create whatever. Blob is like, it's sort of open for you of however you want to use it. And once we do that, there is this Python-based analytical modeling application that runs on a serverless application. So this is also one of the cool new thing that we used was that Microsoft has this concept of Azure functions. So you don't need, in the past, typically if you want to run a Python application, you would need a server somewhere, right? On the cloud or on premise. And you have to go and install Python, and then you will run the application on that machine, right? So you've dedicated a machine and you need to maintain that. In here with this serverless application, what happens is that, like the term says, it is really serverless. It's just a feature called as Azure function, where you go and deploy this Python application, and you can run it as a function, and so there is no server to maintain, no nothing. All you do is that you can connect to that function, and you can make changes, you can do whatever. And then what we do is that that function runs, that Python model runs, and then that modeling is nothing but mathematical modeling, right? So it will read all the data from the blob storage, and it will generate our inventory modeling outputs, right? So all the analytical mathematical model it runs, and then whatever output comes from the model, it dumps it back onto the blob storage. And I have not shown it here, but normally the final step of this is that once the output has come into this blob storage, it gets imported back into the analytical modeling database. And from the analytical modeling database, there is a Tableau dashboard that shows them the output of it. So there will be more fancy dashboard there where they can look at particular region in the world. If they want to just see Asia or Europe or a particular country in, they can drill down, and then they can drill down into a specific material, and Tableau allows all of that. So the one final step happens after this, which is the visualization part. So as you can see, there is like simple Excel file based data that gets picked. There is application, multiple applications, there is databases, there is cloud storage, there is Azure function. And on top of that, the Atom itself is running on the cloud. So today, things have gotten that seamless. If you look at this, it kind of boggles your mind where, what is running where, it's really difficult to nail that down. But, it's resources, cloud resources have become really powerful. So it allows you these capabilities today. So I'll leave it at that. I don't want to make it too much more complex, but I just wanted to give you a sample use case of, and this is just one use case. There is, you can say, I have a Hadoop database, and I need to be able to pull or get data into Hive or whatever, right? You can just think of your use cases, and then it fits in here. You can certainly create an architecture out of it. So with that, I'll stop. If you have questions, good. If not, I will hand it over to Dr. Barate and Dr. Wani.
Question. If you have asked any question, please ask the questions. Very nice presentation by Naveen. Basically, this is the very innovative topic for all of us. So you better way to ask the questions.
There is a lot of cool jargons that gets used, and at times it is intimidating. It makes it scary. But to be honest, a lot of times old concepts just evolve.
Yes.
New names come, and it's just you need to understand them, and they're not scary anymore.
Yes, yes. So I think there are no questions, Naveen.
Naveen.
Hello.
All right,
I
I'll
have
stop
one
sharing so you
question.
can take
I
it.
have one question.
Question. कोणाचा question आहे?
Yeah, go ahead. Go ahead.
Hello.
So I'm not a professor, but sir, I'm a student, and I'm currently pursuing BCA, Bachelor of Computer.
Hello.
I missed that question. I don't know if you completed the question. Can you repeat that, please?
Harshal, please. हाँ, yes.
Sir?
हाँ.
Hello, sir. It's audible now.
Yes, yes, yes. Ask the question.
Yeah. So as I said, I'm a student, and I'm currently pursuing BCA, Bachelor of Computer Application. And thank you for such a wonderful information of IFAS, and it's a very useful to understand the sample case you shared with us. My question is, I'm thinking about the career in data analytics or data scientist. Uh, is it the right career path for me?
So if you are looking into data science or data analytics,
Yeah.
the topic is, they do have a lot of overlap,
Okay.
integration and data analytics, they have certainly a lot of overlap. But if you're looking into data science, it's more into finding meaning about the data, right? A lot of organizations, they have a lot of data, right? The huge volumes
Yeah.
of data is being generated. And the topic of data science essentially came for solving the problem of finding meaning, right? How do we have all this asset, because that is a truly asset, right? I mean, that's organization's asset.
Yeah.
And that is a really valuable asset, right? All this data is hugely valuable, but how do you find meaning? How do you see trends? So data science is really something that enables you to understand and draw meaning from your data. And once you draw meaning, you can understand things in a better way. You can make better conclusions and make better decisions for the organization, right? So data science deals on that part of it. Now, iPaaS essentially deals with integration of data, moving of data, right? So this volume of data also needs to move, right? I mean, they get produced in one place, but they get consumed in another place. And, then they need to get transferred into some kind of a data lake, or they need to reside into. So, over the life cycle, this data keeps moving from place to place. How do you move them in a secured way, in a way where proper people have access to it and not like unauthorized people don't have access to it, things like that. data integration falls in that space, right? So data integration is also very interesting, but you will not be dealing with data science, right? Data integration is primarily dealing with moving of data.
Yeah. Thank you, sir.
And
Thank you so
also,
much.
I mean, the data is like you talked the data science is more so, analytical perspectives, right? But this data moving goes beyond the organization, right? So data moving could be within assets within the organization versus, integration could be that you are talking to your partner, right? So you may be exchanging data with your bank, right? So there is that aspect as well. So, they're while studying, I guess it's fine, but at a point you will have to make make a choice of whether you want to go this way, data science way, or the data integration way.
Yes, sir. Yeah. Thank you. Thank you, sir. Thank you so much.
You're welcome.
Yes.
Any other
Okay.
questions?
I think no questions. Yes. Thank you very much, Naveen.
Thank you for the opportunity. Yeah, it was a privilege.
Thank you, thank you. So I invite G.R. Vani to deliver the vote of thanks for Naveen.
Thank you, Naveen, to deliver knowledgeable and very informative speech on middleware technology and especially on iPass. I also thankful to immediately accept our invitation and took a lot of efforts that to deliver a speech at midnight. I think early in morning at 1 a.m. or 1:30 a.m. at US, and you have
Yes.
delivered the lecture
At that time.
at that
All
time.
right.
So lot of thanks to you. Okay.
Anytime. It was my privilege. Thank you.
Thank you. Now, I would like to introduce today's another resource person and feel proud to say that he is also our alumni of college, our college, Mr. Kiran Bangale.
And also colleague.
Mr. Kiran Bangale is an experienced software architect involved in the architecture, design and implementation of microservices architecture, service oriented architecture and distributed system. He is working as a cloud architect at IBM and has extensively worked with clouds, migration and enterprise architect with more than 15 years of experience in software industries. He has completed a master degree in computer application and bachelor degree in computer science from our college. He filed an US patent and hold numerous certification from Sun Microsystem, the Open Group and Amazon. So welcome Kiran Bangale to deliver a speech.
Thanks a lot,
Oh.
Jarwani sir. I would like to first congratulate and thanks to Dr. Bhusawal sir. Jarwani sir.
हेलो. आवाज थोडा प्रॉब्लेम आहे किरण.
Am I audible?
आवाजात थोडे प्रॉब्लेम आहे किरण. हॅलो. हां हां किरण एनेबल कर म्हणा. एनेबल केलं का? हा, येतोय किरण आवाज?
Is my voice clearly audible?
किरण आम्ही
No, sir, not yet.
Is it clearly audible? Am I audible now?
नो. We are audible, Kiran? Hello?
Is it better now?
Yes.
Okay. So it could be because of bandwidth. Sorry for that. I have switched off my video to enable it. But yeah, if you feel any lag or disturbance, please feel to ping or just let me know. I'll
Yes.
switch it off again as and when required.
Okay.
Yeah. So I just wanted to thank Dr. B.H. Barate sir, Dr. Giarwani sir, and the complete staff of Department of Computer Science Department. And also want to congratulate you all for organizing this national conference on the emerging trends in the computing science. And I have done my BSc Computer Science from the department itself, and I also have privilege to work there as an professor for a couple of years. I started my journey with the teaching, and then have gone through numerous versatile roles like developer, then the tech lead, architect, solution architect, lead architect, and now the enterprise architect. During this my 17 plus years of experience, I have worked on many legacy systems as well as many open source technologies, and have also seen a lot of evolution in terms of architectures, in terms of technology and the trends. So in that context, I will talk on the evolutionary architectures and the cloud adoption and its benefits, how they can be helpful to you while deciding on the architectures and adopting the cloud and its benefits. I hope it is clear. I'm audible and you can see my screen.
Yes.
Okay, thanks. So anything in the software world starts with a requirement. So I don't bother. I mean, what from where the requirement is coming up? It can be by your stakeholders, or it can be driven by business, wherein it can be also driven by the domain, where you get some requirements, you start to analyze them and start thinking to design and implement them. But over the time, you don't have to only work on the requirements, but additionally, you have to also consider the various software architecture characteristics or the different dimensions or non-functional requirements, such as the performance, security, data, legality, if you are dealing with the medical records, and the compliance and scalability, which are closely related to your requirements or the domain or the problem that you're solving. It doesn't matter whether you're working on the enterprise grade of application, you're building a product, or simply you're working in small POC. You have to start with somewhere with the requirements and think and prioritize these characteristics which are out there and decide the importance of them in the context of your application. So if you look at the whole, I'm just presenting you the subset of architectural characteristics. Typically, we call them the elites, and there are so many. I've just taken the subset of it. You can go to the Wikipedia and see the whole list. So it's really difficult to incorporate each and every kind of system qualities or characteristics in your product or in your application. Out of these out of this long list, you have to prioritize and choose the qualities or attributes that are most important to the business. For example, if you are working on the banking applications, so definitely the security will rate or will be at higher level than the performance, right? And this way you will consider the most important one characteristics and try to think of the system design and the architecture which will help you to incorporate all the requirements that are there. And not only requirements, let's talk about a change. In software world, we call architecture as in some stuff which is gonna
Bandwidth
change
कमी होने.
over the time. Okay. Is it better now?
Yes, 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 yes.
Okay. So when we think of any change, we typically think of it as a big change. But in the software world, we know that the changes that we have to deal with are more frequent and smaller chunks. So you have to really think of how you can quickly adopt the new changes, which can be driven by either by the business or it can be driven by the technology. So when we consider or talk about the business changes, those are specifically the changes that are there because you or stakeholder decide to mature the product, or maybe you acquire a company and you want to incorporate the practices of the acquired company in the business, or simply it can be addition of new whole hell lot of features that you want to add or enhance in your product. But the other change which we are left are the technology driven change. So what it means by technology driven change, you cannot only think of the changes which are related to domain or business, but uh, every day or maybe every month or maybe every year, we keep hearing about the new technologies, new trends, and we try to adopt these new technologies in our architectures. For example, if I take a Docker, which change the complete course of implementation of these softwares and packaging of them. So nobody has thought about this kind of technology driven change. They tried to build the architectures without Docker, and then when Docker came into the picture, they tried to adopt the Docker to leverage the benefits which are offered by that technology. So having said that, we know that everything changes all the time in our software world. So the problem remains is like you have built a great architecture and you try to predict something in future that okay, some changes would be coming. But the problem in this process is like you cannot predict the incoming changes in the software world because predictions can go wrong. The only thing which you can do is to create or build a software which is evolvable, which can respond to the changes in a way that it embraces the changes without breaking any existing functionalities and the system qualities. So you're planning about your softwares, how long, how is the long term your planning will be possible when the constant changes are unexpected. And that's why you have to think of a solution possibly which will reduce the degrading of your software gradually over the time. So that's the thought process, that's the thinking you have to apply while designing and architecting the components and the system, so that in such a way that it will not hamper or impact any of the existing functionalities which was previously accepted and was properly functioning in the production. So for that, we have a new term and concept that is out there is a evolutionary architecture. I'll just explain evolutionary architecture definition and their parameters in much depth in the upcoming slides. But an evolutionary architecture actually supports a guided incremental change and across all the multiple dimensions. So when we say a guided, it is actually an architectural fitness function. Whenever you're trying to build something, actually you need some fitness function that provides you an objective integrity assessment of your architectural characteristics. For example, when you say that my application is secure, you need some characteristics for assessment. When you say your application is performant, you should have some metrics, and you should have the ability to apply some testing or assessment on your application. So the fitness functions here can be of different types. Maybe you would measure them by monitoring the your application or architecture, and it will tell you the availability and health of your application. We typically consider to write the unit test cases to check the business behavior. We typically rely on the metrics on the performance level, security, and gradings. We also have some new concept of chaos engineering in the current trends or in market, which is widely being adopted by most of the companies. So chaos engineering is a latest trend which actually helps you to introduce chaos in your architecture or in your system before they occur in production. So what it means that you imagine a specific kind of assaults, like introducing the latency delays or intentionally failing some components of your service, your application, or maybe creating some exceptional scenarios, and see how your system responds to the chaos when they occur in the production. So Netflix, you might have heard about this company or the site, heavily incorporates and practices the chaos engineering. They typically keep introducing the assaults in their applications, and from these experiences, they learn the lessons and they make their architecture so mature that when such kind of chaos actually happen in the production, they don't impact on any functionality of the production application. So there are many tools available to implement the chaos testing or engineering, like Chaos Monkey is there, Chaos Gorilla is there, and some alternatives. But most preferably, Chaos Monkey is very popular and used in the industry. The next parameter that we talked about the evolutionary architecture is the incremental change. So when we talk about the change, the changes can be frequent and can be incremental. For example, in this agile world, we mainly adopt the Scrum methodologies or Kanban kind of agile methodologies to incrementally deliver the changes in our architectures. So your architecture should be flexible enough, or it should be mature enough, or it should be evolutionary so that it absorbs the incremental change without degrading any existing functionalities. And finally, the degree of measurement against the multiple dimensions or the system qualities or the architectural characteristics, whatever you call it, uh, also depends and being measured against your evolvable architectures. So I would like to mention the first law of software architecture is that everything in software architecture is a trade-off. If you think that you have found something that doesn't have any trade-off, then it simply means that you haven't encountered to the trade-off yet. So simply it is proven and experienced that anything you think of in the software architecture is trade-off. Nothing is perfect. I think some of the points already touched in the previous talk by Naveen, like you have to decide a specific tool based on the requirement and then make a trade-off whether you want a performance, whether how your data is being moving between the systems, or you want to go for scalability. And accordingly, your choice of tools, your choice of architecture changes. So I would like to take you through a different architectural patterns that have been evolved over the years. And each of these architectural patterns have their own trade-offs, and they have own their characteristics, benefits, and challenges and complexities. Now it's up to you when you decide on designing and architecting the system, which kind of architecture fits into your requirements, and which kind of architecture responds well to the change, and which kind of architecture incorporates or embraces changes by considering or without compromising the existing software architectural characteristics. Before moving to the architectural patterns, I would like to mention about the architectural quantum term. So what it means, whenever you start thinking about implementing any system, you typically think about its components, its subsystems, and how they interact with each other. So a component may completely be decided by a functionality. For example, you may think of authentication and authorization kind of component, or it can be based on any domain driven context. For example, a checkout process, which involves the multiple entities to make a whole functionality. So depending on that, the architectural quantum is an independently deployable component with high functional cohesion that includes all the structural elements that are required for your system to function properly. And we will analyze the software patterns against architectural quantum, how it responds to the incremental change, how you can apply the guided changes via fitness functions, and how the coupling between the components is there, whether it is low or it is high. Depending on that, it makes the software adaptability to your new changes. To start with the first type of, we cannot say it as an architecture, but this is how we have started traditionally to develop the applications. So it is called as a big ball of mud, whereas you see the red lines are nothing but the integration points between the different components. Those can be classes, or those can be building blocks, or those can be simply subsystems. So you can clearly see that they are really tightly coupled with each other, and the degree of dependency is very, very high. Now, if you try to introduce any change in such kind of systems, you will get a rippling side effects. Altogether, it will definitely break your other functionality without any doubt. The next parameter is like, will you be able to apply the guided fitness functions on this kind of systems? So it's really difficult, because there are no clearly defined partitioning exists there. You can clearly see that from the diagram. And clearly the coupling is very inappropriate. This kind of architectures are now completely undesirable and discarded. Nobody uses them, but this is how initially it had started. The architectural quantum here is a complete entire system. There are no components or no structuring there. Let's move on to the next one. There is next family of monoliths. In monoliths, we have different kind of subtypes. The first one is the unstructured, which is better than compared to the previous one, which we saw, big ball of mud. You have some kind of functionality implemented as a component, but again they are unstructured, and you see the coupling and tight coupling and the dependencies with each other in that diagram. So clearly, if we measure this kind of architectures against the parameters of evolutionary architecture, so large quantum size hinders any incremental change that we want to introduce in these kind of systems. And then if you want to apply some fitness functions, those are again difficult, though those are not impossible, but really difficult to test the functionality and their working in unstructured monoliths. And the coupling is as bad as big ball of mud. And the architectural quantum is a whole entire system. The next type is a kind of a common one, which most of you are working or might be considering to implement small programs or small services, is a layered monolith. In such kind of architectures, we basically slice it out in the form of layers in the application, wherein we separate out the concerns of the layers, wherein presentation presents or contains the components that are related to presentation. Business layer contains the business rules. Persistence handle the persistence related communication. So in such kind of monoliths, you can clearly see that now you have some sort of selective partitioning there. So introducing a change at a layer level becomes selectively easy. For example, at persistence level, if you want to change your underlying ORM framework from Hibernate to IBTs or something else, you would have to only touch upon the persistence, and the presentation and the business layer won't be affected so much. So that's how it is selectively easy. And applying the fitness functions also become easier because now you have some structure which is more apparent there. And finally, the partitioning is there, but yeah, it is not completely desirable. It is not completely decoupled, because if you see, when a consumer calls to your service, it has to go through the presentation, then business rule, then persistence, and then it reach out to the database. So clearly there is a fixed request flow. If anything breaks in between, your system will be down or broken. So that's how it is quite, you cannot say that it is completely a decoupled system. But yeah, this kind of monoliths are a bit common into the very small systems. And the third type is modular monoliths, wherein you consider components which can be grouped or built considering the functionalities or domain-driven context. And then those modular monoliths components interact with each other to make your whole system. So again, the architectural quantum is the entire system, but having some selective granularity at the component level. So the incremental change is now directly proportional to how your component is deployable, how well it is designed, how well the boundaries are defined. And applying the guided or fitness functions are now easier because you have now separation of concerns in the form of components that are implemented in such kind of architectures. Now, since each component is functionally cohesive, it has low coupling compared to the previous types of architectures that we just saw. But again, those are not again at very granular level. Still, there is a coupling, and this kind of systems are preferable when you have simple systems or smaller systems or mid-level systems, but they are not really preferable, or they really fail when you go choose them for the large or complex systems. So let's see what's next. We have microkernel architecture also. Now in microkernel architecture, there are two components. One is a core system, which is nothing but minimal functionality that is required to run your systems with given business rules and logic, custom logic for processing. And then the another component is a plugin module, which is a different module that represents a standalone independent module, which is designed specifically to implement some additional logic or rules. These kind of architectures are basically suitable to design the tools, such as Eclipse is a classic example, wherein it has its core kernel, and then lots of plugins are developed to enable the certain functionalities in the Eclipse. The another example is browsers, wherein there are lots of plugins to enable with the additional functionality, still while still the browser providing its core functionality. So this is preferable for only this kind of applications, because if you see that most of the changes are being applied through the plugins only. So if you have new change, you prefer to create a plugin and plug it into the core system. Now, since integration part is crucial here, the guided functions will be mainly focused for the integration test. You have to ensure that the plugin that is being developed for this kind of core systems are being properly plugged into the system and they are behaving well with the core logic. And third, the coupling is also well defined by this kind of architectural patterns, but this is not the whole solution to all the complex projects. There are still the complete granularity separations are missing out here. So remember that even if you are not providing the or not implementing the 10% of last trap, which is very difficult to achieve, a user will not be satisfied if you don't provide 100% of satisfaction to users. So in such a kind of architectures, they cannot be applicable to every enterprise or large scale applications. But certainly they are suitable for the tools and browser kind of developments. Then the evolution happened, and we had some kind of service oriented architecture families. And they also are divided into multiple categories. So first, let's see the enterprise service bus, which Navin already explained in his talk. So here you can see that you have business services at abstract level at the top, and you have business services at the lower side. Those are the services which are the fat services, and those services implement all the functionality, but these services are stitched together through the message bus. And here there is a lot of burden of configurations and complexities are there. And there are also the application services which helps you in the logging or monitoring kind of or exception handling kind of functionalities. But if your message bus goes down, it can bring your whole enterprise application down, because we rely on some kind of rules or the workflow which is implemented there in a complicated way in the message enterprise service bus. And that service bus actually acts as an choreographer between the services and acts as an service orchestrator at the lower level. So it's really a complex architecture. Again, the architectural quantum is entire system here. Now incorporating new changes, incremental changes are really difficult in such kind of architectures, or virtually we can say those are impossible once your system is built. Again, applying the guided fitness functions are really difficult to measure all the software characteristics matrices like security, performance, and all, which you would decide while working on the software architecture of your system. It's extremely difficult in such architectural pattern. And now the extravagant taxonomy makes it really makes sense only if you want to reuse the same product or same application everywhere within your organization. Otherwise, then they have very less preference in case of the dynamic or the frequent changing applications architectures. So these kind of the components are really extremely coupled in inappropriate ways. So again, these kind of architectures are now not preferred in enterprise grade scale applications. And then there is another family which is called event driven architectures. Those are also part of service oriented architectures. The services at the lower end, you can see that the processes, those are the fat service oriented subsystems which perform specific functionalities to make your whole application. And now you have some data which comes from outside from the, it can be a user event, maybe user is clicking on a video, or maybe some restart happened on a device. So these kind of events come to the system, and you have a challenge to come up with the better event driven architectures to process these kind of incoming messages. So here there are two kind of topologies supported in the event driven architectures. One is through mediator, and another one is the broker. So let's see how mediator works. So whenever the messages come from outside, from the consumer, from users, or from any devices, IoT devices, that can be a car, that can be any computer or anything, those events are processed by the event mediator. Now event mediator is a process, or it's a service which knows the flow of your system, and it knows where to pass the incoming events to the event processor now. But here, since your flow is well defined, event mediator has the responsibility to ensure that the flow is happening in the steps or in the sequence. If anything goes wrong, the event mediator can sense it and can report it back. So you can have better error handling in this case. But then, if you look from the different angle, it's a single point of failure as well. If your event mediator goes down, essentially it will bring your application functionality down. So next, let's see how it measures against our criteria of evolutionary architecture. The architectural quantum is like you build some services, and along with the mediator, it makes your whole system. Now this incremental change is almost similar to the broker. We'll see in next few seconds how broker works. And the guided functions, implementing the integration testing via mediator is bit easier in such kind of architectures, and the semantic coupling is increased there. Relative coupling is increased. In case of broker, you have a clear decoupling between the events and the event processors, wherein it adds a message queue in between them, and all the event messages are kept in the message queues, as we saw in the previous talk. Now this broker has a responsibility to deliver them to the event processor whenever the event processor is healthy, or whenever the event processor wants or subscribe to the channel, they can consume the messages that are published on the specific event channel. Now in such kind of architectures, if you see the architectural quantum is a decoupled events. The decoupling is well defined here, and the problem with the incremental change is like you have to clearly have a deployment pipeline integration, and that's a bit a challenging part here. Otherwise, as you can see, the decoupling is already there. So adding any changes in the event processors can be easier, but then implementing a deployment pipeline for the integration would be a bit challenge. Now the guided functions, fitness functions, are easy in case you are applying them atomically on the different components of your system. But holistically, if you try to test everything all together, then it would be difficult for you. Now structurally, these architectures have the decoupled components, and semantically, they are also decoupled. Now it's up to the choice of architect who wants to decide which architecture is better based on the case study that he is solving or the problem that he is working on. In some cases, mediator is useful, wherein we have to implement a specific workflows, and some cases, in the most of the other cases, the broker one is the preferred one since it is more decoupled. The SOAs were really having a different services altogether, which had all the functionality cohesively implemented. But then again, the problem with the SOS was that they were a shared services. They had a specific interface, the semantically rules how the other services can integrate with them. And if anything changes between any specific service, it's certainly gonna impact on the other services since they are altogether working as in shared services. So a bit granular version emerged in the form of service-based architectures, wherein we tried to decouple the services in the form of service components, wherein they can have the different modules, but still in such kind of architectures, as you can see on the slide, that they are referring to the same database schema, and you cannot have an architecture whose database schema is not changing over the time. So you need some, again, you have some complexity. If your database schema is going to change, all the systems that are referring to that database schema will certainly fail, or you will have to refactor them as well. So that kind of coupling was still there in the service-based architectures. But though compared to the SOS, these were the granular SOS, and the coupling was more granular compared to the SOS. Now, if you look at the parameters, applying the incremental change for this chunkier granular level a bit harms, since the granularity is at a chunky level. You have less freedom to implement the incremental change. But then the scope of you have bigger scope for the test, and you can implement the other fitness functions at the components level in service-based architectures. And when you are implementing the components which are domain centric, for example, as we discussed, if you are considering to build a component based on the domain context, then there are lots of additional benefits when you apply this on the additional architectural characteristics. Now the finer and the granular emerge are the most de facto standard architecture in current world is the microservices architectures. Almost every organization is either on the microservices architecture, or they have plans, or they are actually working on migrating the legacy architectures to the microservices architectures. So let's quickly take a look at how microservices respond to our evolutionary architectural parameters. So if you look at the diagram on the screen, the consumer or the client's requests are interacting with the service components, which are completely decoupled and independent through a common API layer, which is a protocol, which is a network protocol that we commonly refer to it as REST. And you can see that each component had its own database. So if you take a look at the microservices definition, which says that microservices are a little or tiny services which can be independently developed, deployed, and tested. They have their life cycle decoupled. So because of that, making any change within one microservice doesn't impact on any other service within your application. Again, testing of that change will not impact on any other services of, within your whole application. So you don't have to test the any other applications. And again, deployment. It is also made easier because you have to only redeploy the service which has been changed. And resource utilization also improved in this kind of architectures, because now you can scale a specific service at as and when you want, instead of scaling the whole application, which actually results in optimal usage of the resources as well as the cost effectiveness. So there are different characteristics which are associated with the microservices. We have to factor in them while designing the microservices. So first of all, the characteristics that it has is it's distributed in nature. So all the problems, all the complexities that that comes with a distributed system are also associated with the microservices architecture. So you have to take care of the transactions, you have to take care of the distributed data consistency related issues. You have to also take care of the availability of the each and every component within your whole application. Now, since these services are developed independently, the polyglot development can be applied to the microservices, meaning that you can develop the service consumer in Java, while you can have your service developed in C++ or maybe in C#.NET. So that makes it really clearly separation of implementations. It is not completely reliant on specific services. Previously, like since in the monoliths you had to bind to specific technologies, it was really difficult to migrate to the newer technologies or emerging trends, even if you want to, because of the complexities that are involved in the migrations. But now in the microservices, you have that choice to quickly adopt the different technologies for different services that basically fits best for that kind of use cases. The second one, they are separately deployed. As I told, you can have build up pipelines. You can club the microservices with the DevOps practices. Use the automation tools for implementing the continuous integration and continuous deployment, such as Jenkins, Gitflow, and the other available tools to separately deploy them. Now, each of the service has its own all the dependent components built inside the service. So it is completely independent than the other system. So anything, any database schema changes in that services, in that specific service will only affect that specific service, which will not break any functionality of the any other service. If a service goes down, it can break it can fail only a small part of your application. It will not impact the on the whole application. But that was not the case with the monoliths and SOAs. While thinking or while implementing the microservices, you have to also think of what should be the boundary or what should be the typical right size of your microservice. That would be the question. You need some measurement or some practices which will be applied to make a certain boundary for your microservices. So there are few parameters on which you can decide. First is the purpose, whether you are implementing a specific functionality such as authentication or reporting. You will have completely separate dedicated microservice for that. If you have if you want to implement the transactions, now you also have to consider which kind of data consistency you want. Since the transactions in the microservices can go through the multiple services, you cannot rely on the ACID properties which we traditionally used to rely on, since the transaction is happening on the multiple services on the multiple servers. In such cases, you have to design the microservices in such a way that your data becomes eventually consistent. Means after some maybe after few milliseconds or after few seconds or even after few minutes. And then the choreography, which we discussed before, how these services would interact with each other. Since the service interaction is crucial, you have to choose between the different available options, such as a mediator or whether you go for a choreographer pattern, like adding a broker in between them. That really makes your complete architecture, microservices architecture. So while deciding on the purpose, typically we focus on the single functionality or responsibility, like single purpose. And when we think of the transactions, it again depends on case to case or problem to problem, whether we want to rely on the asset properties or whether we want to go for the eventual consistency. Now the additional one more characteristic is the bounded context. As we discussed, like when you are implementing a system, you cannot only consider the functionalities. For some kind of processes, you have to stitch the functionalities together so that you implement a complete context. For example, the checkout process, wherein you have the items as well as you also have the customer information in that. You also have the payment information in that. So you cannot uh, build a checkout process with a single purpose, but rather than we have to consider the bounded context to implement that checkout process. And next is the API layer. Like we also have to think of how these services will be served to the external consumers and how they will be interacting with each other internally. So for that, typically we add a gateway kind of patterns in between, which hides the endpoint of your microservices, which we have developed and deployed. And basically either your user interface can communicate with your microservices through the API layer, or it can the other services can directly internally interact with each other by calling them internally. And finally, the event-driven approach, which we just spoke about. Like if your microservices has some data to communicate with each other, a strategy has to be decided whether to go with the mediator pattern and the choreographer pattern, which will basically enables you to implement the message queue in your system. So at the high level, the microservices at very high level, the microservices architecture would look like this. The clients could be any other service, or it can be a UI. And the API layer is typically API gateway, which acts like a proxy. There are a lot of there are a lot of more benefits also which API layer offers. Um, Apart from hiding the endpoints of the deployed services, like SSL termination, logging, and auditing kind of functionalities also can be implemented at the API layer level. Now let's see how this pattern actually perform against our evolutionary architectural parameters. So if you look at the architectural quantum, these are extremely fine-grained services. So that makes your life easy. If you have incremental change, you can easily adopt without breaking any existing previous changes which you have implemented. And typically in microservices, we adopt the current or latest DevOps practices to implement the automation for the continuous integration and the continuous delivery. And finally, testing is also robust, and you can apply the fitness functions individually across services. And in terms of decoupling, those services are extremely decoupled with each other and extremely fine-grained because they are independently developed and implemented for specific functionalities, and the boundaries are very defined, maybe by considering the functionalities or maybe by the domain context. So this is how the architectures have been evolved over the years, and right now almost every project is being considered to use the microservices architectures in coupled with the DevOps and continuous delivery practices. Those are the best practices. So right now we talked about the evolutionary architectures, the different types of architectural patterns, which can help you to implement your requirement along with the architectural characteristics that are most important to you, and which will also help you to measure your performance of your architecture. And it will also help you to adopt the unexpected changes that come in usually in the business. So once you have built an or decided and designed an architecture, typically the next step comes as an deployment, packaging. So for that, we rely on the DevOps practices in conjunction with the evolutionary architectures. And finally, the next step is the deployment. Now you have gotten your architecture ready, your system is developed, you have built an CI/CD, and next you have to deploy it on the actual server. So you have multiple options there. Either you can choose to deploy your the production ready applications on the public cloud providers such as AWS, Amazon Web Services, Google Cloud Platform, or it can be Microsoft Azure, or you can choose to go with your on-premise cloud, like using the custom hardware and then using VMware, vSphere, or OpenStack kind of technology on top of those hardware. Or in some cases, we can also go with the as an hybrid structure. For example, in terms of banks, they are now preferring a hybrid deployment model because of the data sensitivity. They keep some data on premise while there are certain services which can be deployed on the public cloud providers. So that's how it is. And let's quickly jump on to adoption and how let's see how it can benefit you in your actual application deployments. So to start with cloud, first, what is cloud? So the cloud is nothing but the resources which are provided or hosted by somebody else. Now you don't want to, for example, let's say a Uber system wherein you don't own your car, but you basically rent it out for your purpose. For half an hour, you want to go to a certain point and you order it. You maybe you book it and then you use it. You pay the rent and that's it. You don't have to spend lakhs for purchasing the car and the maintenance of it and all. Similarly, in the computing world, we need certain resources to deploy the applications. Like you need the computing resources, you need the storage resources, you need networking resources. So those resources are typically hosted by the cloud provider. They take the responsibility of those resources. They have become matured in it, and you just ask them for those resources, you pay the rent, and that's it. So let's see the advantages of the cloud, or why you should go with the cloud. So imagine that you have built a great evolutionary, you have chosen great evolutionary architecture, your application is ready, and you have also followed the great DevOps practices, and now you decided to deploy it on your on-premise. Okay. Now, on-premise, you would need the resources which I just spoke about, like the storage resources, computing resources, and the networking resources. So for that, let's say you want to set up your own data center to store your own data. For that, you will have to first purchase the land. It will take lots of time, maybe weeks or months. The next step is you would order the hardware from the companies. Again, the orders that involves kind of lot of time, like placing the order, then the actual procurement happens, and then the resources reach out at your site. Again, you have to think about the security of your data center. You have to think about electricity. You have to think about uh, the um, the lot of other things that are associated. For example, the networking skills, or you need to hire the system administrators who would actually perform the virtualizations on the hardware and who would actually take care of the networking of your hardware. So it will take a lot of time, maybe a lot of months, and till the time you wait for these things, um, you will lose a lot of business opportunities in the market, right? Now assume that still you went ahead, you spent a lot of weeks, months, procured the hardware, and you set up the data center, and now you deployed your application on a specific server. and suddenly you realize that the application is flop or nobody uses it. What will you do with this investment? It will be complete waste or loss of your business. Or consider the opposite situation, wherein your application is the biggest success within a week, and now you have tens of thousands of users or millions of users or billions of users, such as YouTube and the other sites. Initially, you had not guessed this kind of success. So now your existing infrastructure is not enough to host your application. You have only option to left out is procure the new hardware. Again, it would take weeks or months of time. By that time, the user will be disappointed or your existing system will break because of the increasing load on your system. You will be, and that will be again a business loss. So when we talk about a cloud, it actually converts your capital expenses into variable expenses. What it means that you don't have to invest upfront. You don't have to buy land. You don't have to buy the hardware upfront. Those are all the capital expenses, and you never know whether you will test a success or failure. So that's a risk. So it converts your capital expenses into variable expenses. Like now, the Uber case, you know that you don't have to buy a car. You have to only rent it out for a day or for few minutes. The second benefit is scale. As we talked about, since these cloud providers have the massive scales and the massive consumers, they give these resources in very cheap cost. They have built their expertise to utilize those resources very optimally. That's why it is possible for them to offer these resources at a very low cost, and which is benefit of your business. And if you want to scale within few minutes, the cloud providers give you that capability. For example, you realize that now your computing power is being 80% consumed, so load is increasing and you need another virtual machine. You just request it, and within few seconds or minutes you will have the another resource available for you in the cloud. So that's how you can also handle the scale in the cloud. You don't have to guess the capacity. As and when you need, you can demand the resources, and you can pay as you use them or as you go. And as we spoke, it increases the speed to go in the market, and it also increases the agility. And you don't have to spend money on running and maintaining your data centers. And finally, let's say that you have your application whose users are from various continents like India, Africa, or maybe the other Asian countries, or from the USA. Now, a USA user is requesting your website from Mumbai server. It will have a lot of a latency delay, or it will have a high latency. So you would preferably want to serve your USA users from the New York. In that case, again, traditionally, if you think that you have to again go to the New York and purchase the land and order the hardware, but in case of cloud, you can just go to that specific region, specify or spin up the new resources, whatever required to your application, and just go global in within few minutes. So it will have really great experience for your users in terms of performance and latency, and you would also be able to satisfy the different regional constraints that every country has. For example, as we everybody knows that China has a strict regional constraint that the data should be hosted in their country itself. So you cannot have your data center in India and serve to the Chinese users, right? So that way you need to go global and you need to have strategy. So cloud providers enable you to go for it. So when we talk about the computing power, sorry, computing world, we have the various service models that are out there, and each service layer takes care of specific responsibilities. For example, the cloud stuff which we just talk about is the infrastructure as a service. wherein we are relying on the public cloud providers to provide us the infrastructure such as computing resources and the storage resources and networking resources, while the container as a service means it's a latest or emerging trend wherein we are moving out from the virtual machines and packaging our applications so that they can be deployed in the containers which are lightweighted. And containers, in containers our applications shares the resources of underlying host, so that makes it really easy to scale your application in the cloud or even on-prem. And then platform as a service represents the deployment platform or runtime platform, which is involved like when you deploy on your application on server, you need Java runtime installed there, you need Tomcat server installed there, or you need some WebSphere application server installed there. So these kind of resource, the runtime environment, along with some monitoring whether your system is available or not, or some logging and the scaling kind of capabilities are handled by the platform as a service. So and the next service level is the function as a service, which is nothing but which leverage the serverless architectures, wherein you decide what functions you have to invoke on specific events, and then the cloud providers spin up the resources that are required to execute that function, and it fulfills or return back response to you. And finally, the software as a service, which is the responsibility of consumer of a cloud, or it is a responsibility of organization to provide a software service. If we look at any service which is subscription based, like Netflix or Gmail, those are the just an examples of software as a service models. So you really focus on the functionalities, and when you rely on the infrastructure and the PaaS kind of capabilities on the public cloud provider, you really make yourself, you just rent off those services from someone else who is expert in it, and you really focus on the business. Now, just let's quickly see how this global infrastructure is spread. So typically, each and every country or almost 23 regions are covered. I am taking the example of AWS. It is similar to the GCP as well as Azure, almost similar kind of region presence they have. Regions means a specific geography which they represent. It's like an Asia, USA, or Africa. This kind of complete geographies means regions. And within those geographies, they have the different data centers which are connected with each other with very high latency. So almost 70 availability zones are there, and 200 plus edge locations are there. So edge locations act as an nearest server to the users who serve the content nearest to that users. For example, if you are accessing Netflix, which is hosted in US, and you are trying to run a specific movie, that movie would be basically served by the Mumbai server instead of the New York server, because that is most closest to you, and that location is called as an edge location. So every cloud provider typically has categories for compute, for storage, databases, AI, or machine learning, or cost management, or mobile services, and each service has sub services. Similarly, we talked about the trade-offs of each architectures. That way, every service has its own trade-offs and advantages and disadvantages. So based on the kind of problem that we are solving, we have to choose the specific service under that category. So typically every major public cloud provider has 200 plus services available for each category for implementing your application. Now, I quickly wanted you to go through a very simple app and see how it can be evolved in the cloud. And I have chosen a very simple case study because I can show it within the time constraints. Now imagine that you want to implement a site similar to what is the time or what is my IP. And this case study is actually nothing but you have application which returns the time or IP of a user. So user will request to your server, and the application has the responsibility to return the IP of that user. For this simple case study, we don't need a database. That's why I haven't considered it in the case study. And then we typically want to go small, and then in that case we can accept the downtime, some downtime for our application. But when we go or we fully scale, and when the load increases, we want to scale our resources vertically as well as horizontally, and see how we can leverage the services that are offered by the cloud provider without any downtime. So let's go through the cloud journey for this app. So at this moment, I assume that you have gone through all the evolutionary architectures. You have chosen microservices as an architecture for your application. You have implemented it. You have put the DevOps practices out there, and now you want to leverage the cloud platform uh, for this productionizing this app. So if we start very simple, you would think that, okay, I have very handful of users who would be requesting to my machine or my IP, and I will need a specific kind of machine instance. Now in this case, ignore the T2. T2 is a kind of machine instance which has certain processing capacity in the AWS. You just imagine that it is a virtual server where your application would be deployed on a Tomcat. Now the problem is that if your server restarts, its IP would be changed. So you cannot, every time you cannot go to the user and tell that, okay, my server has been restarted. I have got a new IP address, and now you need to request that IP address to get the functionality. That is really not possible, impossible. So in that case, you would use the Elastic IP service provided by the cloud provider, which gives your static IP address, associate with it with the virtual machine, so that even if your virtual machine restarts in future, your user will have to request the same static IP address. And once the user sends a request to know his public IP address, it will be processed by your application, and the user IP address would be returned. Now people started liking your application, and now you have many users. Since you have got many users, and the virtual server which had limited capacity will be unable to uh, absorb this kind of load. So now you decided that, okay, this computing resource is not enough, and I have to have a higher capacity or higher configuration for my server. So in that case, you would just ask Amazon that, okay, I want to migrate from T2 to M5, which is a higher configuration server, higher capacity, which can be handled thousands of users load. So what you have to just go to the configuration, change the type of machine, and your machine would reboot. And boom, you have a enhanced or new hardware that is placed there within few seconds or minutes, and you started serving or absorbing the increasing load on your system. That is the power of cloud. But this is a vertical scaling because we increase the computing power, hardware power of your server, and it has some downtime. When the server restarts, reboots, that machine reboots, there will be some downtime, and if we don't want to experience those downtime to the users, then we will have to think about a horizontal scaling. Now horizontal scaling means what? You will have multiple M5 machines, and the multiple users will approach to these machines for serving their request. So you don't have to reboot the machine. In case once machine is unable to serve the load, another machine will serve the request. But those users have to specifically send requests to those machines. Again, as you know that this is unrealistic architecture. You cannot give a specific kind of users a specific IP address and tell them to access your site from that IP address, and then go to the another set of users and tell them that, okay, use this another IP address for this our application. So instead of that, you would want to utilize the another service that is called a DNS service by the cloud provider, which enables you to configure the multiple machine address at the gateway level, at the DNS level. So you will map these multiple machines or IP address against your domain name, and now the users will only have to know your domain name, like what's my IP.com. And now internally, the Route 53, which is a DNS service of AWS, will take care of redirecting those requests to the different available instances, elastic computing instances. And in this case, you would not require the elastic IP addresses. So it has made your architecture a bit simpler, but since there is a problem, still there is a problem here. Now imagine that the bunch of users are interacting with the first M5 machine, while the another bunch of users interacting with the second, and some users with the third. And what if your one of the machine goes down? Those bunch of group of users will experience downtime, and that is not a desirable situation in your business. So for that, we will utilize a elastic load balancer service which is provided by every public cloud provider, wherein a user will request a DNS. DNS will redirect your request to the elastic load balancer, and now elastic load balancer has inbuilt capability to check the health of existing machine, and it only redirects requests to the machine which is healthy. It keeps checking heartbeats of every machine and see whether it is healthy or not. So it has made your architecture really simpler, because now user will not at all experience the downtime. Elastic load balancer will come to know if any of the machine has down, then it will not send the incoming request to that machine. But still, there is one problem here, that how will you tell elastic load balancer that a load has been increased from thousands to millions of users, and now I want to dynamically spin up a new resource to serve my users on the fly dynamically. So for that, AWS cloud providers give you the capability to use the auto scaling group capacity, auto scaling group service. So what it does in auto scaling group, you tell the cloud provider that, okay, I want to have minimum these kind of instances, and I want to ensure that the specific instance will be spinned up whenever it is required by the load. So let's say your load increase from thousands to millions. The auto scaling group will take care of spinning up the new computing resources to absorb the load. You don't have to manually scale it either vertically or horizontally. It is automated now. Without knowing to us, it will automatically scale up, scale out, and when the load decreases at certain point, it will scale down that machine. So you will not have a cost. You will not have to pay any cost for the resources which are not in service. So let's say the Netflix service, which is mainly used at night or maybe on weekends. On weekends, it will require tens of M5 machines, or at night it will require more computing resources. But in the daytime, it would require fewer resources. So it will be automatically, this kind of automatically scaling out and scaling in capacity is inbuilt in the auto scaling loop. Now, there is still a chance of improvement in this kind of architecture, or there is still chance to evolve our architecture. If you clearly see, all these machines are placed in only one availability zone. One availability zone means one data center. And if you recall, there was a flood in Mumbai in 2006, which actually bring all the services down or all the companies down. So these kind of flooded situations can bring down the data centers down completely. In that case, your application will not be functional at all. So to have some resiliency implemented in your architecture, we can simply design our architecture so that you can distribute your machines across the multiple data centers. For example, few machines would be there in one availability zone, few would be there in the another availability zone. Now, finally, to optimize your cost, the public cloud providers also gives you the additional 60% of discount if you choose to go with the reserved capacity of the resources. For example, instead of going for on-demand resourcing, for example, instead of going for the on-demand resources, you would tell Amazon that you would tell Amazon that, okay, I want so and so reserved instances because that is the minimal requirement of my architecture, and I am definitely going to use at least one server in each availability. Actually gives us more discount, and this will enable us to save more cost. Now, this architecture even can be more enhanced or evolved so that we can have the resiliency across the regions. Let's say all the complete region goes down, then your application will have some downtime. So you can even design your application so that DNS would know that if a specific region goes down, we have to switch back to the another region. And that had happened in case of Netflix, wherein complete US region was down. Still, they were able to serve to their all the users from the UK region. So, but this kind of resilience is rare, and it is specifically useful in kind of very large applications, wherein you need the extreme resiliency. So that's what I had. Basically, I wanted to tell that you can start with any small project. You can keep evolving it. You can think on various architectural patterns and see which one is better fit or which one is helping you to evolve your software without breaking the existing functionalities. And then once the system is ready, you can leverage all the capabilities of cloud and simply go out on the AWS or GCP or any other Microsoft Azure kind of sites, and they offer you 1 year of free access to their services. You may want to experiment those services and try to deploy your production ready applications. So because of utilization of those emerging architectures, DevOps practices, and the cloud adoptions, I can guarantee that within few dollars you can start your startup, or you can have your production ready application deployed and being served within few $100. So that's the thought-provoking things I wanted to present, and rest up to you to explore these things in more details. And in case there are any questions, I will address them. There was a lot of stuff I wanted to cover, and yeah, it's a bit over time, but yeah. In case any questions, please let me know. I can.
Yes, any question?
वाणी सर
हां
येतोय आवाज तुमचा.
ओके ओके okay, thank you Kiran to deliver very innovative informative speech on cloud architecture. Specially thank to accept our invitation. Thanks a lot. Okay, we immediately start next session of paper presentation. The first participant to going paper presentation is Dr. Rakesh Devre. Is Rakesh Devre is ready for presentation? Dr. Rakesh Devre.
ओपन करा ना राकेश देवरे.
Harshal sir.
Yes.
राकेश सर.
Yes, sir. I am ready.
Okay,
Yeah.
sir. Continue, sir.
Yeah.
Okay.
येतो. राकेश सर. राकेश सर. हॅलो. राकेश सर.
हा वाणी सर
हां.
ते जॉईन झालेले आहेत सर.
Yes, you have only 7 to 8 minutes. So complete your Complete your presentation within 7 to 8 minutes only.
Organizing such a nice
राकेश सर, एक मिनिट. राकेश सर,
Am I audible, sir?
तुमचा आवाज तेवढा येत नाहीये सर. जरा.
Yes, sir.
हा सर, ब्रेक होतोय आवाज. कंटिन्यू करा सर. राकेश सर.
हॅलो हॅलो राकेश सर. त्याने त्याचं स्क्रीन शेअरिंग केलेलं आहे.
केलंय ना?
हा ना, आवाज नाही येते ना. हॅलो राकेश तेवढेचा आवाज. राकेश तेवरेचा आवाज का बरं येत नाही? हॅलो 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 येतोय का ना आवाज? अक्षर जाऊन माझा तरी येतोय का? नाही, राकेशचा का नाही येते?
सर,
हा बोला.
थोडा टेक्निकल प्रॉब्लेम आहे राकेश सरांकडे. आताच त्यांचा फोन आला. तर नेक्स्ट कॉल करा ना आपले.
कोण आहे ते? जिंतूरकर आहे ना? नेक्स्ट कोण आहे?
आदित्य जिंतूरकर सर.
हा,
आदित्य सर.
आदित्य जिंतूरकर. There is some problem in the presentation of Dr. Rakesh Devre. So please, next participant present his paper. Professor Ajinkya Jinturkar.
Yes.
सर,
Yes.
जॉईन होत आहेत सर.
Hello.
Yes, yes,
Yes. Yes. Can you hear me?
Yes, yes, you are audible.
Okay. Okay. Can I start my presentation?
Yes, yes, yes.
Okay. Thank you, sir.
Sir, take 8 to 9 minutes, huh? Sir,
Yes, sir.
8
Yes.
minutes.
Yes. It is very short presentation.
Okay, sir.
Yeah. Good afternoon, one and all. So my name is Aditya Jinturkar, and I'm going to present my paper entitled Recognition of Marathi Numerals Using Pixel Density Features and Multiple Neural Networks. So basically, we see that languages, whichever it may be, our mother tongue or any other language, it influences every path of human life. We need a language for a daily routine. So the recognition of handwritten documents in these languages with the help of computers has been a major area for a long period in the pattern recognition. So in the same way, the research work in Marathi language has gained momentum in the last years. So in this paper, the same problem has been discussed, that how we can recognize the Marathi numerals, and the aim was to keep this system as simple as we can. So my paper has mainly two modules. First one is feature extraction module, and another is classification module. So in the pixel density features, I've used in feature extraction module, and in the classification, we have used two mostly used neural network models, that is feed forward and pattern net. So basically, we can see that how the Marathi numerals are, and how they can, when we in case of handwritten numerals, the shape, the style, the strokes, the width, everything gets changed from person to person, and that is what the
एक
problem.
आदित्य सर, एक मिनिट, तुम्हाला पीपीटी शेअर करायचे असतील तर तुम्ही शेअर करू शकतात.
Yes, sir, I have shared actually.
नो सर, कांट
No?
विजिबल टू एनी.
Okay, okay. 1 minute, sir.
प्लीज शेअर युअर पीपीटी सर.
Yes. Is it now visible?
Yes sir,
Yes,
visible.
sir, visible.
You
Okay.
can
Okay.
continue sir.
Okay. Yes, sir. So the related work in this area, uh, we have studied some papers in which the Devanagari, Bangla, and English scripts, the numeral recognition has been developed. The system has been developed. Some of the systems were developed in the artificial neural network. Some used discriminant learning function, as well as some papers are there which reviews the work in this area, which gives the present situation in the indic as well as non-indic scripts. So the proposed method is like this, that we have the training data set as well as a testing data set. So the pre-processing, feature extraction, and training, that is the classification, are the three main steps in this proposed method. The pre-processing operations involves the samples that we take to ready them for the further processing. So the pre-processing operation in the current system involves three things. The firstly, the input image, which is available in the RGB format. It we convert it to grayscale. Then the thresholding operation comes, where we convert that image into black and white, that is binary image. Uh, then we filter that image to remove any noise present in the image. So these are the three pre-processing operations, very common operations in the digital image processing. So we use them to make our samples ready for further processing. The next thing is a feature extraction. So as we can see that it is a very crucial stage, because the further result recognition accuracy is greatly depends on the which features you extract, and which does that features suit your classifier module. So in this work, we have extracted the pixel density features. Again, the pixel density features are very simple and common approach, and they can be extracted with the help of minimum computation. So the complexity of the system remains very simple. At the classifier module, as I have told, we have used two neural networks, feed forward and pattern net neural network. These are the two very widely used in pattern classification area. So we basically want to compare the performance of both the models on our database, on our problem. So both these neural networks are used, and it depends on, so we can see in the next slide that this is the result that we have got. So using feed forward and pattern net, both the neural networks have one hidden layer in them. The number of neurons are in the feed forward, it takes 20 to forget optimal result for the best result, while in the pattern net we required 26 neurons. Both the neural networks were trained using train-LM training algorithm, which is again a very efficient training algorithm in this area. The error function used to calculate the error was mean square error. The layer 1 transfer function for both the layers, for both the neural network was TANSIC, while the layer 2 transfer function differs in feed forward. It takes pure linear as its transfer function. We got recognition accuracy for the feed forward neural network 97.77%, nearer to 98, while in the pattern net neural network we got the recognition accuracy 95.55%. So here we can see some of the graphs where I want to show that how the precision and recall it changes across the numeral classes. So we can see that most of the numerals gives us the 100% result, 100% precision as well as recall for many of the numerals. So the conclusion of the thing is that the recognition accuracy of the neural network model used is depends greatly upon the data, the training data that you are taking for the neural network, the number and type of feature extraction techniques you have used. So, and that's why due to these parameters, the performance of neural network model varies from one problem to another problem. So in our case, that what we have just seen, the feed forward neural network performed well for our problem than pattern net neural network. Yeah, the difference was not that much, but the feed forward neural network slightly outperforms the pattern net neural network. So here I end my presentation. I end my short presentation. Thank you for giving me opportunity to present my work before all the dignitaries. Thank you very much.
Thank you, sir.
Yes.
Thank you. Have you implemented your
Yes,
request?
sir.
Yes,
Yes,
sir.
sir. Yes.
On which platform you used?
Sir, I normally use MATLAB, sir.
Yes, yes. Very good. Very good.
Yes. Thank you, sir.
Next participant?
Any
Hello.
questions?
No, no, sir. Any question from audience?
Thank you, sir.
Okay.
Thank you, sir. Thank you. Thank you.
Our next participant is Shubhangi Patil, madam. Shubhangi, madam, please continue.
Yes, sir. Am I audible?
Yes, sir. Yes, ma'am.
Okay. Good afternoon.
Good afternoon. बोला.
Is my screen visible to all?
ते पाईप का वर जाता नाही. हा.
Good afternoon. Myself Shubhangi Patil, and today's my presentation topic is performance-based analysis of various image
आपल्या
segmentation
कलेक्शन
techniques. Digital image processing is an important and essential area in today's scenario. Several problems can be solved by computer vision technology. There are number of challenges and opportunities addressed in the field of digital image processing, out of which one of the most challenging tasks in digital image processing is image segmentation. The fundamental objective of image segmentation is to extract the various objects or regions that inside the image, which are used to analyze the image, and also by using which we can obtain some useful information from it. It is mostly useful for many other applications. In this paper, we present some analysis of various segmentation techniques such as age detection, thresholding, region-based segmentation, and feature-based clustering segmentation. Besides this, some of the image segmentation techniques are tested on microscopic blood smear images. Now, what is image segmentation? Basically, image segmentation is a process of dividing images into multiple segments, such as set of pixels in the regions that are similar to each other, to extract or to identify the different objects or different regions in an image. Here is one of the example of image segmentation. The original input image I have taken is a blood smear image of microscope from microscope, and it contains red blood cells as well as white blood cells. And the task I want to perform is to extract the white blood cells from the original image. By using the segmentation techniques, as you can see in a segmented image, white blood cells can be extracted. The image segmentation is basically applied in many areas of digital image processing. The major area of image segmentation application is image compression and object recognition. In object recognition, such as fingerprint recognition, face recognition, character recognition, or in medical diagnosis, such as detecting the tumor, or number of pathological diagnoses are in the then robotics also. In the image segmentation is used in to locate the object in satellite images. There are some image segmentation techniques which are basically based on properties, two properties such as discontinuity and similarity. The discontinuity present in an image is point, line, and edges. And the similarity based segmentation techniques includes thresholding, region growing, and region splitting and merging techniques. Segmentation techniques can be classified as age detection, thresholding, region-based segmentation, and feature-based clustering. Segmentation by age detection. The age detection techniques are generally used for finding the discontinuities in an gray level image. These discontinuities includes point, line, and edges. The edge detection technique works well for images having good contrast between the regions. Spatial mask can be used to detect all the three types of discontinuities in an image. There are some there are some edge detection operators like Sobel, Privet, Robert, and Laplacian of Gaussian. Sobel edge detection operator is Sobel edge detection operator is basically used to detect the edges where the gradient's magnitude is high. This makes Sobel edge detector more sensitive to diagonal edges than the horizontal and vertical edges. This mask is typically used to find the approximate absolute gradient magnitude at each point in an input grayscale image. The mask used to detect the horizontal edges and vertical edges by using the Sobel edge detector detection operator is as shown in the figure. Also, after applying this operator, I got this result shown in the figure. The another edge detector operator is private edge detector operator. This the private edge detector operator correctly estimates the magnitude and orientations of an image. It is simple to implement, but this operator produces somewhat noisier result. It is discrete differentiation operator, which functions similar to Sobel by computing the gradients for image intensity function. It makes use of maximum directional gradients as compared to Sobel. Private mask is simpler, but it is very sensitive to noise. The mask used for edge detection using private operator is as shown in the figure, and the result I obtained while applying the private operator is as shown here. Also, the another edge detection operator is Robert. The Robert's cross operator performs a simple, quick to compute 2D spatial gradient measurement on an image. Thus, it highlights regions of high spatial frequencies, which often corresponds to the edges. It works best with binary images, and pixels value at each point in output represent the estimated absolute magnitude of the spatial gradient of input image at that point. After here is the mask for Robert edge detection operator is given, and after applying the Robert edge detection operator, I obtain this type of result. Then the Canny edge detection operator. This edge detection operator uses multi-stage algorithm to detect a wide range of edges in the image. To remove the noise effect from the image, in Canny edge detector operator, Gaussian filter is used. Canny operator also implements three parameters such as low error rate, localization, and single response to a single edge. The output obtained by using the Canny edge detection operator is as shown here. The another edge detection operator is Laplacian of Gaussian. This operator requires some type of pre-processing. It firstly reduces the noise and smoothed the image with a Gaussian filter, and then the Laplacian operator is applied to detect the edges. Because of this, it gives a double edge image. Locating the edges then consists of finding the zero cross between the double edges. The digital implementation of Laplacian operator uses the following mask, and the result I obtained after applying this Laplacian of Gaussian edge detection operators are shown in the figure. Then the edge detection techniques works well for image having good contrast between the regions, but there are some disadvantages to this these techniques. These techniques not works well with images that contains the edges which are ill-defined, and if the image contains too many edges. Also, it is less immune to noise. The another segmentation technique is thresholding. Thresholding is one of the most efficient and simple way in which partition the image into the foreground and background. It is most effective for the image with high level contrast. Thresholding requires that the histogram of an image has a number of peaks. Each corresponds to a region. Thresholding can be implemented by global thresholding and adaptive thresholding. Global thresholding, object and background pixels are separated by comparing with chosen threshold value. The Otsus threshold value of boundary block is used to classify the object and background in an image. In global thresholding, if the image contains non-uniform illumination, then it may be failed. After applying the global thresholding onto the original image, in output image, I can separate the background and the objects from the original image as shown in the figure. The next thresholding technique is adaptive thresholding. It is also called as local thresholding, and to deal with non-uniform illumination, multiple thresholds are used in this technique. Then by using this initial threshold value, image is segmented, and as the pixel within threshold follows one segment and other follows as another segment. The process is repeated until the threshold value mismatch with pixel value. The threshold value is repeatedly obtained for each segment in this process. After applying the adaptive thresholding, the output image obtained is as shown here. This thresholding technique also suffers from several problems, like the thresholding technique is based on histogram. So it may be difficult to identify significant peaks and valleys in the image. Spatial details of image is not considered. Hence, segmented regions may not be continuous by this method. The another image segmentation method is region-based segmentation method.
Madam, your time is over. Please make conclusion.
The region-based segmentation method is also a similarity-based method. I implement a single seeded region growing method, and the next one is feature-based clustering method, which contains k-means clustering. Finally, this paper examines the performance of various segmentation techniques using the subjective evaluation on some microscopic image of blood smear in age, and we concluded that out of the age detection techniques, any operator gives best result, whereas within thresholding algorithm, global thresholding and adaptive thresholding produce good result. The global thresholding technique recognizes the object very well, as well as the adaptive thresholding produce good edges. The single-seeded region growing segmentation divides the image into the different parts according to features in the image, and the output of feature-based k-means segmentation technique varies according to cluster size. As the cluster size is more, percentage of accuracy obtained is also more. The result of image segmentation techniques affected by some of the factors like homogeneity of images, texture and content of image, noise present in the image, and the noise present in the image, and some of the spatial factors of the image. Thank you. Here are some references of my research, of my work.
Thank you, madam. Thank you. Who is the next presenter?
Next presenter is Divya Joshi, madam. Hello. Divya Joshi, madam.
Hello.
हाँ मैडम.
येतोय सर?
हा एक
थँक्यू.
दिव्या जोशी मॅडम.
येस सर.
हा प्लीज कंटिन्यू मॅडम.
ओके. Good afternoon, everyone. Myself Divya Joshi. My topic name is data mining techniques and application. What is data mining? Data mining is the process of uncover patterns in huge data sets. Data mining is the process of examining data and encapsulate it to produce useful information. Data mining is uses widely data analysis tools to discover design and relationship in large database. Data mining tools allows a business organization to predict customer behavior. Data mining is nothing but it refers extremely knowledge from the large amount of data is known as the data mining. So there are data mining techniques are categorized into two ways, that is descriptive mining and predictive mining. Descriptive mining is nothing but it identifies what happened in the past by analyzing stored data is known as descriptive mining. And second one is predictive mining. It describes that what can happen in the future with the help of past data analysis. So this, with the basis of these two techniques, there are some tasks which are used in data mining. That first one is the classification. This classification is the predictive mining technique. Classification is used to retrieve important and relevant information about data and metadata. This data mining method helps to classify data in different classes. Classification consists of predicting certain outcome based on given input. Classification is the systematic approach to build classification model from input data. This is a classification process. There are two phases in classification, learning phases and classification phases. In learning phases, in this process, the data are analyzed by the classification algorithm. And in classification phases, the data is used to measure the precision of classification rules. Classification makes use of mathematical techniques such as decision tree, statistic, neural network, linear programming. These all are the algorithms that are used in the classification techniques. First is decision tree. Decision tree is a flow chart like structure. Each node denoted testing of an attribute value. Each branch represent outcome of test. Leaves represent decision. Here, this is an example of driving license. If the age is greater than 18, then it is eligible. And if the age is less than 18, then it is not eligible. Means this algorithm shows result in yes or no. Means it take a decision in yes or no. So this is a decision making tree. Next is statistic algorithm. Statistic, this is a data mining technique. Statistic is the branch of mathematics which related to the collection and description of data. It helps to discover the pattern and build predictive model. In today's world, people have to deal with a large amount of data and derive important pattern from it. Statistics can help you to greater extent the statistic can help you to greater extent to get answer the question about their data. That the question may are like what are the patterns in their database, what is the probability of an event to occur, which patterns are more useful to the business. Statistics not only answer the questions, they also help in summarizing the data and count it. It also helps to provide information about the data with case. Through statistical report, people can make smart decision. There are different form of statistics, but the most important and useful techniques in the collection and counting of data that are mean, median, mode, max, mean. See, these are the lots of ways to collect the data. Next one is the neural network. Neural network is the another technique used by the people those days. This technique is most often in the starting stages of data mining technique. The artificial neural network was formed out of community of artificial intelligence. A neural network consists of an interconnected group of artificial neurons, and it processes information using connectionist approach to computation. Neural networks are very easy to use. They are automatic to a particular extent, and because of this, user is not expected to have much knowledge about the work and database. But to make the neural network efficiently, you need to know how the nodes are connected, how many processing units to be used, how when should the training process be stopped. So there are two main parts of these techniques. The one is node and the second one is link. The node, which is freely matches to the neuron in the human brains, and the link, which freely matches to the connection between the neurons in the human brains. So neural network technique has been used in the business to detect fraud taking place in the business. Now next one is association rule. Association rule is another technique. It is the descriptive mining technique. This data mining technique helps to find the association between the two or more items. This technique discovered a hidden pattern in the data. This technique is most often used in the retail industries to find patterns in sales. This will help increase the conversion rates and thus increase the profit. For example, market-based analysis. In market-based analysis, they use that help to identify which items should be purchased together. Assume that there is a large amount of data, large amount of items like tea, coffee, milk, etc. Among these, customer buy the subset of items as per requirement, and market get the information of item which customer has purchased together. So the market use this information to put the item on different position. So association techniques have a two steps process. They find all the frequently occurs data sets and create strong association rules from the frequent data sets. Next one is application of data mining. First application, there are so many applications, but in my article I explained only two. First is healthcare. Healthcare data mining is become increasingly popularly in healthcare. Data mining provides the methodology and technology for healthcare organization. It evaluates treatment effectiveness, manage healthcare at different levels, so save lives of patients using predictive medicines, manage customer relationship, detect waste, fraud, and abuse. So how does data mining works in healthcare? Data mining is used as a part of knowledge discovered in database. The whole process includes data selection, data pre-processing, data transformation, data mining, and data evaluation. Data mining in healthcare is used mainly for predicting various diseases, assisting with diagnosis, and advising doctors in making clinical decisions. Next is credit card fraud detection. Billions of dollars have been lost of the action of fraud. Traditional methods of fraud detection are time consuming and complex. So data mining helps in providing meaningful pattern and turning data into information. So the credit card fraud detection, that to design of the neural network architecture for the credit card detection system was based on unsupervised method and credit card fraud detection system using four clauses: low, high risk, and high risk. So conclusion, data mining is proved to be an important tool in many areas of business, and techniques are best used in deriving solution to a problem. It is very crucial for companies to use data mining techniques to help the business people to make smart decisions. All the data mining techniques should go hand in hand to solve out an issue.
Thank you, madam. Who is next?
स्मिता बेंडाळे मॅडम. स्मिता बेंडाळे मॅडम.
Make the slide show. Okay, shall we start, sir?
Please continue, madam.
Okay, thank you. Good afternoon to all. We are attending the e-conference arranged by the computer science department. I am Smita Bindaye. My topic of presentation is COVID-19 is an opportunity to Indian Railway for development. I am trying to put forth this idea in front of you because this is the period of COVID-19, which it is a pandemic to us. It is a problem to us. So how we can overcome this problem, or how we can overcome this problem by supporting to a Indian economy through the railways. I am just trying to put forth this idea. Please, next slide. Sir, please make the slideshow. Okay. Ms. Shilpi Bishnoi, the Director of Traffic Commercial of Indian Ministry of Railway. She is believing that this crisis of COVID-19, it's an opportunity to create a new business model, uh, by understanding the demand of its passenger and a freight segment, and that the railway have to focus on the three important areas. Means she is trying to consider that this crisis is just like as an opportunity for the Indian Railway, that how they can use the demand of the passenger, and how they can make the freight segments, and how they can understand the freight segments, and understand the important areas, because Indian Railway is the backbone of the Indian economy. And for that, for saving our economy, or for supporting our economy, the Indian Railway have to understand how to solve the problems regarding the earning the money. So for that, facing that critical conditions, the Indian Railway have to define the different business strategies. Now the next slide is the introduction. Move to the introduction, sir. Hello. Hello.
इंट्रोडक्शनच केलं ना मॅडम.
Okay, ठीक आहे, thank you, sir. Okay. In the means the year 2020-21, this is the year in which we show the pandemic of COVID-19, which at the national level also, or at the international level also. Means we are facing the different types of problems regarding the earning. Indian Railway plays a very important role in our Indian economy, and of course for the people of India. So as per we consider, the overall share of the railway in a freight traffic is around 35%, and it is continuously trying to capture the market, because we have to make the transportation of the bulk commodity, just as coal, iron, cement, food grains. These are the main runners or drivers of the Indian economy, and because of this we can capture the market. And for transportation, the railway is a very big media, but because of the COVID-19, it affected on the transportation sector, and Indian Railway also affected because of this. In this third quarter of 2019-20, Indian Railway freight had already begun to show the sign of marginal decline. We have to face the marginal decline, and we have to face the reduction in the rate of the core sectors. Core sector means our 8 core sectors that we have to consider. Different core sectors हैं हमारे, तो उनके बारे में consider करना चाहिए. So these sectors have the reduction. These sectors also get the decline, the diminishing level. So because of this, the railways also get the marginal decline. So as per the Shilpa Bishnoi, this is the opportunity of the Indian Railway to capture the market, to take the hold on the market. How? Means it is the choice of the Indian Railway. They can get this chance to face this current situation, and capture the passenger and freight transportation fragments. This is the right time to look and think beyond the current year position, and try to up to the growth map of railway for the next 5 to 10 years. Now move to the next slide. What are the objectives of this research? This is I have suggested here the three objectives, not like a suggestion, but it is my objective by studying this article. In that, the first is to put the very suggestive view in front of the people for getting this topic in a realistic manner. Means because of this article, we can say that this article is very helpful to us. And I study that article, and with that article, I write this research paper. So I trying to put this idea in front of you. Second is to focus on the three important areas which state the new model of business for development of Indian Railway. These models are explained in my analysis. Next is to study the concept of remodeling the freight businesses, how we can consider the remodeling freight business concept. This is the very good concept for the development of the Indian Railway. Now the scope of the research. The focus of this study is to restart our economy and increase our business. हम कैसे हमारे business को बढ़ाए and try to apply the new mode of business which can be possible by offering the right freight rates, designing of a new business strategies, and by guiding the customers and reaching out to the railways. That is how we can enhance the will of doing business. कि जैसे हम अपनी business की we have to enhance the will of doing our business. Next is now the main body of the research, means my analysis. Move to the next slide, sir. Okay, this is my analysis. In that, we have to consider about these 3 points. That is acknowledging the passenger fragments. Second, remodeling the freight business, and diversification of the freight traffic. In that, first we have to see the acknowledge the passenger fragments. Means we have to recognize the passenger fragment. What is the demand of the passenger? What is the segmentation of the market? What is the need of the market? Yes, sir.
You can continue, madam.
Okay. For recognition, when we recognize about the passenger demand, when we understand the demand, what is the demand of the passenger at this current position, for that we have to consider about the two important factors, that is necessity and viability. What is the necessity of this condition and what is the viability, means what is the need of the market, means what type of alternatives we can available to the public through the transportation medias. Because of the railways, we can available the different things to the public, different things to the people as per their demand. And because these two criteria we can because of this criteria we can consider about the alternative mode, just like affordability of the rail compared to others, means what type of medias that other we have available for the transportation. We have the road also, we have the air also, but how we can improve the using the media of railways. In that we have we have the metros. Just like using this transportation system, we can increase the earning of the railway. Means if we and for that we have to increase the presence of people in this segments. And how we can increase the presence of this presence of public in this segment, that we have to complete the requirements of the people, and for that we have to launch the new business strategies for the railways. This is the period of May, June and July. It's like a blank slate for the Indian Railway, and for that we have to renovate the new things. We have to make the new things for the passenger in this bad segment. So for proper understanding this fragmentation, or for understanding these segments, the Indian Railway has to consider about the essential journeys. What type of essential journeys in Indian Railway have to plan, and what type of journeys they have to postpone. And after that, what type of journey medias we can available to the public. हम करना है जीरो बेस एनालिसिस, मींस हमारे व्हाट इज आवर बेस, हमें जीरो से शुरुआत करनी. दिस इज द फर्स्ट कंसेप्ट, दैट इज पैसेंजर freight business. Remodeling of freight business, remodel the freight businesses of traffic. For increasing the freight traffic, capture the public, we have to we have railways from the road, and how that we have to make we have to increase the freight traffic. For that, sources to the public, rolling stock, manpower, increase our volume of working. Means we have to create the competitive transportation. When we make the improvement, when we make the competition in that, then to the Indian Railway of the freight traffic. How we fight the freight traffic. 19. Indian Railway, but this is the opportunity need parcel trains and containers or cargo. We can successfully aggregated and transported. And because of this, we consolidate and as similar scheduled parcel trains. And because of make the transportation of the now the next slide. This research helped the Indian Railway business strategy. Second is this research analyzing about customer segments and their look. Remodeling freight businesses help focus more on traffic, including network capacity, manpower, and last is this is the opportunity the parcel trains and container cargo. Is a conclusion. I can conclude that uh, this is the period of COVID-19, and in this can powerfully increase their use this period as an opportunity for their development. Goods, pharmaceutical goods, fruits, vegetables. They means different types of logistic, and they can increase their business. Okay. Some people, the American politicians, you never let a serious crisis go to do things you think you could. Thank you, sir.
Thank you, madam. Please, Dr. B.H. Barate, sir, please continue the next section.
Thank you all the research participants who present their papers here. I think there are 4 to 5 researchers are again interested to present their paper, but due to a long time we cannot proceed our conference more. That's why I again thankful to all the participants who registered in our conference. This is our first try to organize such a e-conference and presentation of papers through this conference. We all are from the computer science background, and that's why this is the one of the way to start the sharing of researchers with one another through this meeting, through this online platform. I request all the researchers from this as a conference organizing secretary that they submit their full research papers before or on 1st June 2020 with their total plagiarized report as well as copyright form. After accepting all the research papers, the final e-proceeding will be distributed on 5th June 2020 to your registered email for this conference. If you have any problem about your research papers before 1st June, you can mail us or directly contact to us. But I again request you to submit the completed research papers in the discipline or given format by the conference. Submit as early as possible, since we can provide our e-proceeding in time. Thank you very much, and I call to Dr. Gauri Patil Madam for final session of this conference, that is for vote of thanks. Dr. Gauri Patil.
Good afternoon, everybody. On the behalf of e-conference, on the behalf of the one-day national e-conference organized by Department of Computer Science, Bhusawal Arts Science and Nahata Commerce College, Bhusawal, on the topic of ongoing research in computer science, I would like to thank our patrons, Dr. Mohan Bhau Falak, Mahesh Bhau Falak, Vishnu Bhau Chaudhary, Nahata sir, our principal, who always guide us and encourage us to organize such a type of events. Before this, we organized the 5 conferences which are organized in person, and now this is our first conference which is organized online, that is e-conference. For this conference, we get the guidance of officiating registrar from KBC North Maharashtra University, Dr. B.V. Pawar sir, who always bless us and guide us to arrange such a type of event and have knowledge distributed by them. Next, I would like to thank the eminent personalities who guide us during this e-conference, Mr. Naveen Singh and Mr. Kiran Bhangaye, who are the ocean of the knowledge and gives us the knowledge who they have. They try to distribute their knowledge, give the knowledge to all of us. I would like to thank our Vice Principal and HOD, Dr. B.H. Barate sir, who help us to organize such type of events. I would like to thank to Dr. G.R. Vani sir, Harshal sir. Harshal sir, especially thank to you to successfully organize this Zoom conference on the Zoom without any technical problems. I would like to thank to all the teaching and non-teaching staff who helped to organize this e-conference. Thank you very much.
थँक्यू मॅडम. तर लिव्ह व्हायचं का नाही?
हो.
काही मेसेज द्यायचा आहे अजून?
काही नाही, ऑन सांग.
Thank you, sir. Thank you to all the participants. Goodbye. Take care.
Okay.